Well, welcome everyone. My name is Bruce Belzowski. I'm the Managing Director of the Automotive Futures Group here in Ann Arbor, Michigan. We're here for the EV Challenges and Opportunities Conference, looking at policies, consumers, and what was the third one? It's policies, consumers, and company strategies. We've got a good set of speakers talking about these topics as well as others, and looking forward to discussion with people online as well, people who are in the audience here at the U of M. So, as I said, my name is Bruce Belzowski. I'm retired from the University of Michigan Transportation Research Institute, and this is my information if you want to contact me. Our funding comes from three major sources: our affiliate program, our research, and our conferences. Our affiliate members are, as I said, one of our main contributors to our funding, and we could not do these conferences without them. So we really appreciate them being part of our group. Always a shout out and a thank you for them. Our research partners across many different organizations. We have IT organizations, OEMs, governments and NGOs, as well as suppliers and consultants. Our research projects this year are looking at our propulsion strategies for the 21st century. This will be coming up as one of our next conferences. We also have a survey coming out in late May, early June. Our EV Evolutions project kind of combines all the things that are going on in EVs in China, the US, and the EU. We have a website that's dedicated to that. And New Mobility is a conference that we put on just in February, focusing on all different variety of topics related to new mobility. We're also, for this conference, we're going to be talking about a recent survey that we put out for electric vehicles, challenges and opportunities. And also one of our other major topics is globalization of the industry. And right now that globalization is really focused on electric vehicles. Our researchers, we have Kara Elkhire, who is our research associate. Kara's online right now with the YouTube live stream. If you have questions, you can put that into the chat and interact with her. Our student researchers, some of them are graduate students now. Some of them are graduating soon, and some of them are younger students. So we use them for a lot of our research throughout the auto industry. We urge everyone to join our LinkedIn page. We're posting 2 to 3 times a week, looking at issues related to our conferences, of course, but also discussion of our research and any things that are going on in policy and the automotive news in general. And so that we encourage everyone to join us and follow us. So our next conference, as I mentioned, is in July. It's July 18th. Our 15th annual Propulsion Strategies for the 21st Century. We'll be looking at the future of battery technology. So for this particular conference, we're not going to be talking too much about the battery technology. It's more about policies and consumers and company strategies. And we're really focusing on battery technology in July. And in September, it's our 15th annual Future of Automotive IT. And this year, we're looking at artificial intelligence in the vehicle and in the organization. Again, only for the auto industry, of course. And this is what we'll be doing in September. For conference logistics, we've got three speakers: Chris Harto from Consumer Reports, Greg Keolian from the University of Michigan Center for Sustainable Systems, and Brandon Boyle from Roland Berger. Oops, wrong picture. And that is not Brandon. We don't have the right picture on that one. But we'll start out with Chris. We'll do a Q&A. Greg Keolian will follow. We'll take a break. Then I'll talk about our recent survey results. Then Brandon will come in, and then we'll adjourn, and people here will have lunch. Post-conference, all the attendees will get a link to the presentations and the video. It'll be on our website. Affiliates will get the presentations, but they'll also get a review of the highlights of the conference that Kara will be working on. All the agenda, speaker bios, registration lists, sponsor opportunities, affiliate information, upcoming events, those are all on our website, our EV Challenges and Opportunities conference website. We sent that link to you in the email that we sent you. Audience questions and conference feedback is important. There's two ways of asking questions. For the people here, there are Lydia is going to be putting out the question cards for you to, if you have questions that you want to ask, she'll be putting those out, and she'll bringing those to me here. Kara is going to be monitoring the questions in the chat in the YouTube live stream, so feel free to enter questions there as well. And I think also in the emails that I sent you, there's a link to a Google Doc that allows you to enter questions. So please feel free to use those. This is an important part of the discussion within the conference. So let's start talking about some of the challenges and opportunities. Some of the slides that I put up earlier in intro for the conference looked at a lot of the issues related to EV challenges, the charging in terms of availability, reliability, the cost, who's the ownership of the chargers, also vehicle costs and affordability, depreciation, used vehicles, consumer knowledge and education of EVs, and of course, battery technology, mining, materials, processing, creating cells, creating packs, battery management systems, hot and cold weather, R&D and new materials and designs like pack to structure. All these things are just so important to the development of battery technology and development of EV technology. And we're really at the early days of this. So as I said, our next conference is going to be focusing on that. Also, battery production and recycling and worker transitions are some of the bigger challenges that we're facing. When you look at the opportunities, you see reducing greenhouse gas emissions. You see improved air quality. You see lower operating costs for vehicles. Increase energy security through multiple energy sources as you use, because electric has wind and solar and natural gas as part of their sources for the energy. There's, we talk about worker changes as a challenge, but it's also an opportunity for job creation, for innovation, for new economic opportunities. And of course, enhanced energy storage from what we're learning about batteries. So when you look at some of the recent EV policies, we've talked a lot about these. This has been going on since the infrastructure law that was passed, and last year the Inflation Reduction Act has so much stuff to do with electric vehicles. But the goal of the government is to make 50% of all new vehicles be zero emission vehicles by 2030. Multiple charging stations are going to be built on major routes, and so that EVs have reliable charging. Rural areas will also be given priority for new charging stations, where they're expecting about 500,000 chargers by 2030. The IRA has the light duty EV tax credit. It extended to 2032 with a tax credit of up to $7,500 per EV, but it has some requirements for MSRP for vehicles, and we're going to be finding out from Treasury probably within I think April 18th we're going to be finding out which vehicles actually qualify. When you look at the used vehicles, this is another issue that I think is an important thing for us, in particular because it reaches more people than the used vehicles, than the new vehicles. You get a tax credit for up to 30% for the up to $4,000 for these vehicles. It has to be bought by a dealership. Prices must be less than $25,000. Vehicle must be at least 2 model years old. And used vehicles can only qualify for the tax credit once in its lifetime. So these are used vehicle issues that are important. You look at what's going on in the used EV market. Just recently, the used EV market has tripled in size. This is since April of 2021. The EV prices are dropping since August of 2022. And also we see things changing because of this. See a 20% increase in these listings as of January 2023. Also, in terms of, this is an example showing some of differences on used vehicle prices. And we're also the drop from just recent that's going on just recently. But I think on the right-hand side, you're really looking at a very interesting thing having to do with the prices of the used vehicles, where you've got a significant number now coming in under $25,000 and under $30,000. When you look at one of the other issues having to do with vehicles of used vehicles, when you start talking about what happens over time, is the degradation of the battery in terms of the range. This is some information from a group called Recurrent that studies this. I think they have a panel of EV owners. And looking at here, we're looking at the Tesla Model 3 at the 3 different variations that are part of the Model 3. And you can see that there's a range of changes in the range of the vehicle over time based on the number of miles. But what's interesting is that it does level out. And so that when you're getting up at 100,000 miles, it's pretty similar to where you were at about 50,000 miles. So this is a really good sign, I think, for at least for the Tesla models, because of the batteries being different in all the different manufacturers. Each model may be different in how they react, but this is a good sign for these models. So when it really comes down to it from a policy perspective, these are the main issues that we're following, right? Where they've eliminated a 200,000 vehicle per manufacturer cap, but there's an MSRP cap, there's an income cap, there's a tax credit as a rebate. Then there's the issues about assembly, final assembly in North America, critical value requirement of minerals, critical minerals, foreign entities concern rule, battery component of percentage of value requirement, battery component foreign entities concern rule. All these are going on, right? Still being dealt with right now. So we're finding new things about this all the time. We look at what's going on with Treasury and changing the policy. So they're expecting a new deal has just been made with Japan came to an agreement so that they can to get at least a half of the credit, around $3,750 for vehicles that may be not depending on where they're actually where all the different details that we talked about in terms of the minerals and the battery, where the battery comes from, where the vehicle is made. All those issues are now part of the U.S.-Japan agreement, and there's also negotiating another agreement with the EU on the same topic. So there's a lot of things changing in terms of the EV policy from Treasury. So when you look at the plan, now when you look at all this and looking at what the administration is doing, it looks like the administration is focused on building out the U.S. EV supply chain and charging infrastructure first, rather than pushing for a lot of immediate EV sales. They have incentives for EV sales, but they're kind of a lot of things are tied to that. So in particular, they're really focusing on trying to get the supply chains into U.S. and North America. One of the big reasons is that manufacturers and suppliers aren't ready, and the rebates, as we all know, last until 2032. Now, getting used EVs into the mix, I think, is a great idea. There's 2 to 3 times more used vehicles sold annually than new vehicles, and allows non-new vehicle owners to get into the game. So I think that's a really good plan from the from the government standpoint. Looking at EV charging, there's at-home charging. We're looking at some satisfaction issues. Satisfaction is highest among owners with level 2 chargers, as opposed to level 1 chargers. We've got some data from J.D. Power looking at home charging. So this is at level 2 charging stations, looking at the different companies that provide chargers for home. Tesla being the benchmark, the segment being about 740 in terms of the index rating that J.D. Power uses. And you can see some of the companies that are above that and companies that are below that. So we know there's a lot of work to do, because we've heard of problems where not necessarily at home charging, but when you look at public charging. Public charging says that 20% of the respondents in the survey said their charger that they tried to use didn't work. Said it was because the station was somehow broken or out of service. Cost of charging is also an issue. It's not as transparent as probably we would like it to. It's not the same as going to a gas station and looking at the prices per gallon and knowing exactly how much you're paying and what you're paying for. Of course, even at a gas station, you don't know the sales tax, the state sales tax, the federal sales tax that is all part of the gasoline price. So the charging cost, but it's not transparent to anyone who pulls up to a charger to know how much they're going to be paying for their charge. Location also heavily impacts satisfaction levels. It's interesting that the state of California, people are more, they find that the public chargers are less available. Whereas in other regions where EVs aren't as popular, people are pretty satisfied with how many are available. Of course, in California, there are many, many more EVs available, and that's probably part of the problem, is that there's more people charging and that there are not enough available public chargers. So I think this is obviously an area, and we all know this is an area that needs a lot of improvement. So from a public charging standpoint, you're looking at 2 J.D. Power studies here, or same study, one looking at level 2 charging stations, one looking at DC fast chargers. The Tesla taking the lead again for both of these, with the segment average, and some of the other companies trailing in terms of what they're doing in terms of level 2 public charging and DC fast chargers. Again, a lot of work to be done here. But some manufacturers decided, like Tesla, to do it themselves. Mercedes-Benz is launching their own EV charging network in North America later in 2023. They're expecting more than 10,000 chargers in China, Europe, and the big markets. They want to provide a Mercedes experience for their buyers. Other EVs will also be able to use these chargers, but Mercedes drivers will be able to pre-book charging time and will be given priority over others. This is something that we think that is that the future will hold for charging, where you will be able to get a place in line to say, I'm going to be at this charger at around this time, and they will probably give you, a grace period of 5-10 minutes. And then you will have that charger, and that charger will not work for anyone else during that time. And I think that will be an interesting and a very nice way of being able to deal with not having access or coming to a charging station and finding that they're all full, or that they're not working. VW is doing their own charging network as well, but they tend to be, like many of the other manufacturers, they're partnering with the companies that are providing charging, and they're using those chargers. Now, how those will work out throughout the different charging networks and making appointments for charging will be interesting to see how that's going to play out. But there's also going to be doing some of their own as well, I think. And where's all this power coming from? Well, in the U.S., 2022 was the first time that renewables overcame coal in terms of generating electricity in the U.S. And where the renewables come from primarily is wind, then hydro, then solar, and then biomass geothermal. This really is a good sign for the U.S. In terms of the growth of renewables. So we're looking forward to seeing more of that in the future. In terms of battery development, $64 billion has been announced in North America for battery manufacturing projects by OEMs and major battery manufacturers. This is a work that, and we'll be talking about this at the conference in July. Kara Elkhire will be doing a presentation on this work that she's been doing for the last year on batteries and the battery development from investment standpoint, but also recycling and mining and materials and minerals and materials. So it'll be an interesting talk, but this is some of the things that she came up with. We got the Department of Energy and Argonne, one of our affiliates, showing where the planned battery plants are going to be, and how many gigawatts per year that will provide by 2030. And also some of the companies that were getting awards from the federal government. This came from the infrastructure law, $2.8 billion awarded to 20 companies. As you can see, they're spread out across the U.S. Some of it mostly could be battery manufacturing, but some of it could also be for recycling. And here we have the 5 of the major battery recycling companies that have received money from the US DOE. And sometimes some of it is grants, some of it is loans, but it's a lot of money. And these companies are really starting to set up in sometimes near manufacturers, sometimes away from the manufacturers. They're working with many different manufacturers to provide recycled material for the future batteries. When you look at product, we put together some slides on current EVs. Here, this is a listing by manufacturer. Now these vehicles have been, some of them have been on the road for, Tesla has been on the road probably almost 10 years now. But other companies are relatively newer to the EV fleet. And you look at, this is both the all the manufacturers that we have in the US and the vehicles that are being sold. But there's also a lot of upcoming EVs. So if you look at the 23, 24, 25, and we don't have too much going on in 26 yet, But the data that we found, thank you to Car and Driver as a source for this, there's a lot of other vehicles that are coming up across multiple manufacturers and brands. So we're looking forward to the introduction of these vehicles in the near future. So currently, there's no companies that have a full lineup of EVs across all the major segments, but more are coming, as you could see from the slides. We continue to wait for the under 30K EV. Incentives may help with that, but manufacturers are struggling to make profit on their luxury EVs and are limiting production in order to manage their profit and loss. Americans seem to want a vehicle that matches all their needs, even if many of those needs rarely occur. Some EV buyers are buying an EV, but they're keeping their gas vehicle to make sure that all their needs are met. Major difference between the US and China. Most of the Chinese EVs are smaller with less range than US EVs. They're also much less expensive. And they're also there are as many plug-in hybrids sold as EVs. So it's a different mindset in China. Of course, Tesla and NIO and Li Auto, these are the luxury brands in China. They're also selling, but there is a another level of mid-size, mid-range price range and low end in China that we don't see in the US. There for a lot of different reasons, as I was talking about, the customers are not really excited about buying a vehicle that doesn't meet all their needs. And especially if they're used to a vehicle getting 300-400 miles on a tank of gas. The thing is that because if you can charge at home, you can charge, your vehicle is recharged every night. So you do not have to worry about not having, if you can get a vehicle that has 200-mile range and that vehicle can charge every night at home, unless you're actually driving more than 200 miles a day, this will meet your needs. It's when you go on your longer trips that you start saying, what am I going to do with this? How am I going to charge this? How often am I going to have to charge? So that's my kind of intro to the conference, to give you some insight into some of the work that we've been doing. I'm going to stop my share now. I'm going to bring in Chris Harto from Consumer Reports. Chris, you with us?
Yep. Thanks, Bruce. Sure.
Chris Harto serves as the Senior Policy Analyst, Transportation and Energy for Consumer Reports, Washington, D.C. office, where he leads research on clean vehicles, fuel economy, energy efficiency, clean energy, utility policy, and other energy and environmental topics. Chris has over 15 years experience performing research and analysis supporting federal and state agencies. His alma maters include Arizona State, where he was an inaugural member of the class of school sustainability, and Ohio State University, where he studied chemical engineering. Welcome, Chris.
Thanks, Bruce. Yeah, so I'm going to talk about a new report Consumer Reports put out last week, really digging into the supply and demand dynamics happening in the EV market. So it's really time to hit the accelerator on EV production, and we'll show you why. But first, I'm going to start with a little bit of an ecology lesson. So in ecology, there's this law called Liebig's Law of the Minimum. And what it states is that growth is not dictated by the total resources available, but the scarcest resource. So the limiting factor. And what that means really is that, if you're growing corn and it doesn't matter how much fertilizer you put on your corn if you don't have rain, your corn's not going to grow. Similarly, if you have lots of rain but you don't have fertilizer, your corn's not going to grow. So how does this apply to the EV market? We hear a lot of talk about barriers to EV adoption. Bruce talked a lot about them. Things like charging infrastructure, price are two of the ones that really jump to the top. But really what we've found, and through our research so far, is that the number one the primary limiting factor to EV adoption in the US is supply. That's it. It's supply. Every EV that is built is being sold almost immediately. There's wait lists. There's no supply, no vehicles sitting on dealer lots. Very few vehicles sitting on dealer lots. So despite all of those barriers to long-term adoption to EVs, really right now and potentially into the future, the biggest roadblock is EV supply. And the rest of my talk will really dig into why that is. So what did we find in our study? So our study really dug into the deeper levels of some of our survey results over the past few years. Top line, we found that in the past couple of years, EV demand has increased 350%. Really, what seems to be driving that is that in that time frame, we've gotten a lot better EVs have hit the market. Vehicles like the Mustang Mach-E, the Ford Lightning, Hyundai and Kia released the EV6 and Ioniq 5. The vehicles that are hitting the market are really orders of magnitude better than the EVs that were on the market really for the past decade before. Those tended to be shorter range, compact vehicles, not in segments consumers really want. Compact cars, no matter what the powertrain, are not very popular. Those vehicles had very short ranges. They were very limited vehicles. The vehicles we're starting to see automakers release now, we're seeing pickup trucks, we're seeing SUVs. The average range is now in the 250 plus range, which really allows consumers to do 95% of their driving just charging at home and only really needing public charging for those occasional longer road trips. So that's really created a whole new paradigm of consumer demand for EVs. When we dug even deeper into those results, we found that what our results really represented is that there were 36 million American adults who would definitely buy or lease an electric-only vehicle, so a battery electric vehicle, if they were to buy or lease a vehicle today. That's 36 million Americans today. Actually, when we fielded that survey in the middle of 2022, so almost a year ago, 36 million Americans ready to buy an EV. The next time they go to buy a vehicle, they want an EV. That's a lot of Americans. How does that compare to the number of EVs being built? Well, last year was another bumper year for EVs, another huge growth year for electric vehicle sales, but still only 800,000 EVs manufactured and sold to consumers. So that means right now there are 45 EV-ready buyers. There's 45 Americans who want an EV for every EV that's being manufactured. We also found data on publicly reported paid reservations for EVs. That number was close to 2 million Americans who have put, not just people who've raised their hands or given their email address, but 2 million Americans who've paid money to stand in line to get an electric vehicle. And this only accounted for about a quarter of the new EVs that are coming to the market, either just came onto the market or coming to market in the next year or two. So there's this massive line of EV interested buyers who are just sitting there waiting for their opportunity to buy an electric vehicle for the manufacturer of their choice, the vehicle that they're most interested in, to get built and sold to them. But that's the picture today. That's what is already happening. That's data from the past. What is the future like? And we're really seeing 4 major trends that are likely to drive massive growth in that number of Americans who are ready to buy an EV today. Those trends include cost declines, and I'll go into these into more detail in a second, but cost declines, improving infrastructure, increased consumer experience, and increased automaker investments. And these 4 factors all work together to really create a virtuous cycle that's really supercharging consumer demand for electric vehicles. So what about cost declines? We know that in surveys, cost is a top barrier that consumers say to EV adoption, but we see it rapidly receding. For one, Bruce talked about the Inflation Reduction Act tax credits. Those also include tax credits for domestic battery manufacturing. That doesn't get a lot of attention, but somewhere on the order of $3,000 to $5,000 in tax credits are available for manufacturers building batteries in the United States. Those cost savings don't necessarily immediately show up in the MSRP, but they show up in the bottom lines of the companies building these vehicles and allow them to, give them more profit margin and the ability to lower prices as they scale up. In addition, with tax credits and all of the tax credits that we've seen from the Inflation Reduction Act, there are a number of analyses that show that many BEVs, battery electric vehicles, are already at cost parity or will achieve cost parity in the next year or two as they qualify for those credits and the manufacturers capture the value of those various tax credits to lower their production cost and lower MSRP. Furthermore, even without tax credits, there's a wide range of these types of analyses, but basically every single one of them that I've seen shows that EVs without tax credits will achieve cost parity sometime before 2030, which is really within one product cycle. We're roughly 7 years from 2030. That's on the order of one product cycle in the traditional auto industry. So we're less than one product cycle or less than one product cycle from all EVs really being at or below cost parity with their comparable gas vehicle. And I just show an example here of one that very much already is at cost parity. We've got the Chevy Bolt here, 2650 is the MSRP, plus the vehicle qualifies for tax credits. We don't know exactly where it'll shake out with the new rules, probably $3,700 tax credit for the Bolt is the most likely scenario going forward. Compared to the Toyota Prius, historically the cheap, affordable efficient gasoline vehicle that consumers buy. And we can see that even without tax credits, the MSRP is close to $1,000 more on the Prius than the Chevy Bolt. So, depending on what you think of the Bolt has some limitations, but for consumers that works, the Bolt is already at cost parity with similar gasoline powered vehicle. Next up is infrastructure improvements. Again, the number two, the number one barrier, cost is actually number two to EV adoption is infrastructure. Consumers just don't have the confidence in the infrastructure out there quite yet. But coming to the rescue, we have the federal government investing $7.5 billion over the next 4 years to really beef up that national charging network. The plans include ensuring that there are charging stations every 50 miles along all major highways in the US to really make sure that consumers who buy an electric vehicle can have confidence that that vehicle they buy, they can drive anywhere that they want to go in this country. That federal money also comes with strings attached. There are uptime requirements, there's reliability requirements, there's a whole bunch of requirements on that money to ensure that not only do those chargers exist, but those chargers are reliable and are there when consumers need them. But it's not just the government making investments. We're also seeing significant increases in private investment in charging infrastructure. And a lot of that is tied to companies that see this as an opportunity. These companies know that consumers are going to have to sit there for 15, 20, 30 minutes waiting for their car to charge. And they want to take advantage of that time where consumers are charging to convince them to buy things. So we have a number of companies who have announced large charging investments for that purpose. Specifically, Walmart just came out last week or the last 2 weeks talking about wanting to build a massive national network of charging infrastructure. As we know, there's a Walmart basically everywhere there are people in the United States. So that really presents a huge opportunity for expanding charging infrastructure, especially in more rural areas. Similarly, 7-Eleven is investing huge in charging infrastructure, Starbucks and Subway sandwiches. So all of these are big national brands. They have reach across the entire country, and they're really investing big bucks to expand charging at their locations. And we believe that this increased confidence in infrastructure will, again, drive increased purchase demand. This one's less understood and less talked about, but we see consumer experience as really the factor that will, the wild card factor that will really supercharge consumer demand. So this is from our survey last year, and we looked at consumers interested in buying electric vehicles with their direct experience with electric vehicles. So we created an experience score. So this was a score of 0 to 4, and it was based on consumers' answers to 4 questions. Have you seen an electric vehicle in your neighborhood? Do you know somebody who owns an electric vehicle? Have you ridden in an electric vehicle? And have you driven in an electric vehicle? So if you'd answered no to all of those questions, you got a 0. And if you answered yes to all of those questions, you got a 4. So to put that into perspective, what a 4 means is, do you have the same level of experience with electric vehicles as the typical 16-year-old with a learner's permit has with a gasoline vehicle? So it's a very low bar to jump over, but as you can see, many Americans don't even have that very minimal level of experience. But what we find is when Americans do have that level of experience, that just base understanding of an electric vehicle, how it works, experiencing the instant torque and quiet acceleration. Once they have that level of experience, their interest in buying an electric vehicle increases tenfold. So compared to consumers with no experience with an EV, consumers with an experience score of 4 were 10 times as likely to say they would definitely buy or lease an electric vehicle. So the more electric vehicles that are sold, the more friends, neighbors have electric vehicles, the more people who rent an EV on a business trip, it's it's just going to accelerate that demand even further. Finally, we have automaker investments. Automakers do eventually respond to consumer demand. They tend to be fairly slow, but they do eventually respond. And we're seeing it. We're not seeing it necessarily in the vehicles sold today. We're seeing it a little bit in the vehicles sold today, but we're seeing it really in the investments. The automakers have announced global investments of $860 billion, including $210 billion in announced investments in the United States. And most of these investments have been announced over the past couple of years. So this is a massive amount of capital going in to addressing the supply problem and scaling up electric vehicle production. We saw from Bruce's slides the huge number of new EVs that automakers are planning to release. They're releasing more vehicles in more volume, in more vehicle classes, and at more price points. And that's just going to increase the number of people who see an electric vehicle that looks like an option that they'd really like to consider when buying their next vehicle. Further, that those investments will really help scale the industry. One of the challenges with EVs and really any vehicle that automakers build and make, when you build a fairly low volume of any vehicle, it's going to be tough to make a profit when you're only selling 15, 20, 30,000 units of a vehicle. The economies of scale really improve when you start to hit those volume numbers, when you start producing 100,000 or more of a model. It allows you to spread your R&D costs. There's a lot of fixed costs that can get spread across those vehicles. They can really help drive down the cost of manufacturing those vehicles. So really those four factors work together and are really going to supercharge demand over the coming decade. So that's the demand side. What about the supply side? What is we talk a lot, the industry, when we talk about cars, it's always focused on new car sales. Every discussion of electric vehicles that I see is always focused on new car sales. New car sales will be 50% by 2030, 100% of new car sales by 2035. New car sales of 25% by 2025. It's always framed around new car sales. I think that's a mistake. And this figure here on this slide is complex, and I'm going to talk through it for a while. But really, it takes a long time to turn over the vehicle fleet. New car sales turn over somewhere between 6 and 7% of the fleet every year, which means even when you're at 100% new vehicle sales, it takes a long time to turn over the fleet, to get those vehicles into the hands of consumers. So that's what this slide is trying to show. The black line is the projected EV supply in terms of the total light duty fleet. So not new vehicle sales, but total light duty vehicle fleet. And it's based on an assumed sales curve that takes into account the EPA standards for 2026, President Biden's target of 50% EVs by 2030, and GM's target of 100% battery electric vehicle by 2035. So if we follow the curve from where we are today, people talk about getting out of the early adopter phase. Along this supply path, the auto market doesn't leave the early adopter phase until roughly 2031. That means we haven't gotten EVs into the hands of 16% of Americans until 2031. That's the point at which we go from the early adopters to the early majority. The early majority are the people who are a little bit more, they're a little bit more wait and see than the early adopters. They need a little more evidence, but they're going to be, more on the early side of purchasing a vehicle. We enter the early majority in about 2031 and stay there till about 2038. So 2038 is again, on this trajectory of 50% sales by 2030. 2038, we finally achieve 50% of the vehicles on the road in the United States being electric vehicles. So that's 15 years in the future, even on this accelerated path, until we get to 50% penetration of the fleet. And then, taking it to the far end, the laggards, these are the people who are least likely to adopt an EV. These are the people who are probably most likely to comment on Facebook about how they're never going to buy an EV. They don't become relevant to the market until the mid 2040s. So more than 20 years into the future, that's when we really have to work. On one hand, this means that consumers who want EVs actually are probably going to have to wait. There's gonna be some patience required as it just the dynamics of the car market mean that it's going to take a very long time to saturate the market. So it means a lot of people who want electric vehicles are going to have to wait. We show here on the left part of the diagram with the colored sections. The lower green section is people who said in 2022 that they would definitely buy an electric vehicle today. And again, we have enough of those people to take up all of the EV supply until 2030. Then we move into the group that said they would seriously consider an electric vehicle today when we did our survey in 2022. Again, we have enough of those people already seriously considering an EV to eat up all of the supply until 2035. So, on one hand, we have a lot of people waiting for EVs that are probably going to have to continue to wait. And we also have some time to address those concerns for the people who are in the late majority, in the laggards, who are really, maybe a little skeptical of electric vehicles. Maybe they don't think they're not confident in the range. They're not confident in the infrastructure. They're too expensive for them to purchase an EV yet. We have some time to address those concerns. I know I'm running out of time, so I'll keep moving along. So what happens to those people who are waiting? What happens to those people who want an electric vehicle today, but for whatever reason, automakers haven't scaled up? They're, they just can't get one quite yet. There's a significant risk to automakers from those consumers. In a different survey, in our car buying survey, we found that 30% of licensed drivers who are then in the market to buy or lease a new and not used vehicle were not even considering a conventional non-hybrid vehicle. What that really means is that roughly 30% of the new car market has decided, I'm not going to buy a conventional gasoline vehicle anymore. I'm not even going to consider it. I might buy a hybrid if I can't get the EV I want, but I'm not going to buy a conventional gas vehicle. That's already 30% of the market has said, no, I'm ready for the next thing. And if you don't provide it, maybe I'll just buy another used vehicle, or more than likely, they'll just hold on to their existing gasoline vehicle longer while they wait for the automakers to supply the vehicle that they do want. And this is actually, showing up in the data. This isn't just people telling us they'll do that and then going ahead and buying the gasoline vehicle. Gasoline vehicles, conventional ICE vehicle sales have dropped 26% between 2019 and 2022. cumulatively 9.4 million fewer ICE vehicles were sold in the 2020 to 2022 time period. Yes, supply chain crisis. So there's a lot of reasons why there wasn't supply out there, but what we're seeing today is what we saw last year. In 2022, roughly 1 million more vehicles were produced in the United States than were sold. So a lot of that was building up inventories that were drawn down during the pandemic because of production challenges. But we don't see gasoline, conventional ICE vehicle demand going back anywhere close to what it was before. We just see this lower demand for vehicles that are increasingly viewed by consumers as obsolete or soon to be obsolete. And so automakers really need to factor that in to their plans for the future. Because there's a very reasonable chance that even if you don't produce the EV that the consumer wants, they may not buy the conventional gas vehicle that you want to sell them, at least not without significant discounts, and those discounts will cut into the profitability that automakers are hoping to rely on to fund their transition to electric vehicles. So looking ahead to 2032, I wanted to talk briefly about the news reports over the weekend about EPA's greenhouse gas standards. They reported that the EPA may propose standards that require between 64 and 70 or 67% EVs by 2032. To put that in perspective, even if that is the trajectory that EPA proposes, that will still result in fewer than 20% of Americans being able to own EVs by 2032. And just to help people visualize what 2032 is going to look like, here's what a typical BEV will look like in 2032. We will have achieved cost parity. The vehicle will have 300 to 400 miles of range. We'll have ubiquitous charging infrastructure. Consumers will be able to recharge around 200 miles of range in no more than 15 to 20 minutes. That vehicle will have $15,000 to $20,000 lower lifetime operating costs, and it will be faster, smoother, quieter, and than the comparable conventional ICE vehicle. When you look at it from that perspective, beyond towing, what is the consumer value proposition for buying a new ICE vehicle in 2032? I think it's going to be very hard to sell a significant number of conventional gasoline vehicles in the early 2030s when battery electric vehicles look like this. I think there will continue to be some demand for gasoline ICE vehicles, especially in towing, certain niches in the market, certain parts of the country, but, selling 50, even 30% of the market being gasoline vehicles, I think is very optimistic for automakers. And that creates real challenges for them in their future and their profitability. So I'll close here saying, it is time to hit the accelerator. If the company does not already have a plan to be at 100% within, a decade or a little longer, I think companies are going to run into some real challenges. And this is not to say that I don't understand the challenges that automakers face. I'm just saying that consumers may not care. Consumers want what they want, and they won't necessarily buy what they don't want. And so automakers really have a really tough time balancing the exponential growth in demand for their currently unprofitable EVs and the potential rapid decline in their current profitable ICE business. You're really having to balance two exponential curves that have real real implications for the long term, the short term profitability and long term existence of your company. But with all the data that I've got, that I've seen, really, to me, the biggest risk to automakers is moving too slow and not moving too fast on your scale up of EVs. So I'll leave it at that, and with just the final statement of, don't be like these guys at the bottom. Transitions happen slowly and then all at once, and we're getting very close to the all at once point for EVs. And that's my talk. Bruce.
Very good. Thank you, Chris. When you were looking at the people who are doing reservations,
Yep.
did you break that out by OEM?
No, I don't. Well, there are some. Yeah, I just took the top level numbers. I will admit that I took that analysis from a Recurrent who has a blog post on it, and I've been promised by the researcher that they will update that soon. That 1.92 million people was from a blog, a research piece they put out last summer. I know they're working on updating it, so we'll hopefully see some new numbers soon.
Okay. I thought you made a great point about the company credits that were going to help support the EV development and production for the manufacturers. That's a point that I was not as familiar with. So that really should make a huge difference for the manufacturers and the suppliers.
Yep.
One thing you didn't mention in your talk was, and I think you started out with that, with the limiting factors.
Yeah.
Now, when you look at materials and mining and the kind of the rules for that the government is putting in place, do you see that material story as being also one of the major limiting factors?
It's certainly an excuse automakers are making. Whether or not it ends up being a true limiting factor, I think it's ultimately going to be a competitive factor, and the automakers who manage their supply chains the best and make the best deals and plan ahead and secure those resources will be best positioned to do well in this transition. I don't necessarily see a fundamental limit in those resources, but it certainly automakers who think they can, I think there's going to be more responsibility that automakers have to take over their supply chains, and probably more than they want to or have, and definitely have historically done. So it's absolutely, I would put that in the challenges for automakers. But again, if you want to exist in the late, mid to late 2030s, you're going to have to figure out how to solve that problem. And, certainly policy can help them, but the consumer demand piece and where consumers are and where we need to be for climate, again, I think it's not a fundamental limit. It's just a challenge.
Yeah, that's a big question when you look at what is happening with a report that came out from the United Nations about us reaching the 1.5 degrees centigrade on our current path by mid 2030s compared to the original idea, which was going to be 2050. Greg, you can jump in on this if you have any.
Yeah, I was just wanted to follow up because I was wondering about where in the supply chain, what is the limiting factor? And there is lithium mining, but then there's battery production, and then you need the assembly plants and the rest of the supply for those vehicles. But I don't know, Bruce, if you've looked at that as well in terms of battery, plant availability.
it's one of the issues that of course that the manufacturers struggle with, right? They always have purchased steel and aluminum and iron. They didn't have mines. You know, now some of the manufacturers are actually getting into mining and supporting mining of particularly the materials for the batteries, right? Something that they never had to do before, but it's not like they've never done anything having to do with this, but I think it makes the vertical integration story where manufacturers do more things internally and trying to control their own destiny by doing this. It seems like something that they're just going to have to do. If Chris's point is if that you're actually going to get some credits back, some tax credits back for doing some of that work, that's going to be really supportive for the companies to do that.
Yeah, I mean, I completely agree with Chris. This has to happen and it needs to be accelerated. But, you know, there are supply chain challenges. The other complexity here is that the chemistry, battery chemistry, is also changing. And, you know, when we talk about lead acid battery, that chemistry hasn't changed. And this is much more, much more complicated. And the battery, the asset is, could be 30% of the cost of the vehicle. So it's, this transition is challenging, and that's the focus of our.
I agree. Chris, one of the audience members brought up the point about your sample for your survey. These were people who were they EV potentials or this random sample?
It's 8,000 nationally representative sample of Americans. So it's a nationally representative sample. We also have data in that 30% number of people not interested in buying a conventional gas vehicle. That was a different sample. That is specifically car buyers, people who said they were in the market to buy a new to them vehicle over the next year. So we have data from both the broad population, which was where some of the first numbers came from, and also data from new car buyers, people who are planning to buy a car in the next year, either new or used. And we see a much stronger interest in electric vehicles among the new car buyer segment than we do among the used car buyer segment.
That's interesting. Yeah. Good point. Yeah, well, they're just so there are more used EVs coming into the marketplace than there were in the past, but nothing to the volume that ICE vehicles have.
The bottom line is people can't buy a vehicle that doesn't exist. And that was really the point of that graphic I spent a lot of time on, is that, there's only so many EVs that are going to be in existence, even on some of these very accelerated sales pathways. That's going to make it, take a long time for consumers to be able to get their hands on these vehicles that many of the, a rapidly growing number of them want.
Chris, do you see any safety focused regulations or standards from the U.S. government in place for EVs?
This is a question that comes up a lot, and I do find it kind of interesting that we haven't cared about the safety of big, heavy vehicles, and automakers have spent the last 20 years complaining that fuel economy requirements were going to force them to build smaller, less safe vehicles, and now we have EVs that are going to be slightly heavier, and now we're all concerned with weight, as we've been selling nothing but SUVs and monster trucks for the past, decade or more. So it's, in our analysis of safety, there is some trade-off there in which a bigger vehicle is, a heavier vehicle is safer for the occupant and a little bit more dangerous for everyone else on the road. And that nets out kind of close to zero, give or take, depending on the assumptions. So, but yeah, that said, bigger, heavier vehicles are more dangerous to everyone else on the road. But I don't see it as an EV only problem. I see it as a challenge across the industry. That said, I haven't seen any regulations coming down the pike that are specific to vehicle weight. We do have a lot of advanced safety systems that are going on new vehicles that should help reduce the frequency of crashes, which should help things like automatic emergency braking, pedestrian detection, blind spot warning. A lot of these features should help reduce accident frequency, which again applies to all new vehicles, not just EVs.
Got a couple questions about cost parity, Chris.
Yeah.
Does cost parity mean a purchase price or cost of ownership?
Purchase price. We have analysis from 2020 showing that even back in 2020, most EVs on the road were at cost parity on a total cost of ownership over a typical ownership period. Basically right at cost parity, despite their higher purchase cost back then. We're hoping to update that analysis sometime this summer with all the changes that have happened in the market since then.
And does the cost parity apply to SUVs and pickups as well?
Yes. Yep. In many cases, those vehicles do quite well in the cost parity because they're fairly expensive. The gasoline versions are very expensive. So yes, that's in all vehicle classes, that analysis.
Okay. One of the questions that came up had to do with charging stations, and some of the issues you're talking about was interesting because you want to have a lot of drive to get more EVs on the road. Will the charging stations be there, when they get there? This is kind of a timing piece, right? In terms of and it will have an effect on people's view of EVs, and positive and negative, depending on what kind of experience they have with the chargers, right? Go ahead.
Yeah, no, it's certainly a challenge. Part of the challenge is that really outside of Tesla, we didn't have very many fast charging capable vehicles on the road before just 2 years ago, before things like the Mustang Mach-E and the Kia EV6 and the Ford Lightning. A lot of these vehicles that have been released in the past 2 to 3 years have really been the first fast charging capable, really road trip capable vehicles on the market. So we've had, and the charging infrastructure in a way really wasn't ready for those vehicles because there was no demand for it before. Before you had mostly short range, quick, not fast charging vehicles. So there wasn't any demand for it outside of Tesla. That investment by the federal government should go a long way to help. But the other side of it is that the people who are buying EVs today typically own their home, they own another vehicle that is gasoline powered vehicle. So we have some time. Again, looking at that adoption curve, we're only in the, even over the next few years, we're only going to be in the single digits of Americans having electric vehicles. And a lot of those people own their own home, they have another vehicle. And so the charging is less of an issue for those people. Where it does become an issue is when we get to 2030, 2035, when we have a much broader adoption of electric vehicles throughout the population, that charging infrastructure really needs to be there. It has to be there. So it's an issue. We have some time to fix it. It's not going to fix it on its own. So we do need policy, and we do need to do work to make sure that it is there. But yeah.
So we looked at your experience score, which was a very interesting way of trying to tease out some of how people think about EVs. There's also the story of how do people progress from 0 to 4. And
Yeah.
I guess one of the questions is how long does it take, or will it take, for people to progress from a 0 to 4? 4 doesn't mean you're actually buying a vehicle. You're more willing to consider that vehicle, right?
Yeah.
How do you see that transition going?
Yeah, it's kind of the same way any other technology goes through society. And in some areas, it's going to be faster. In some areas, it's going to be slower. And it's kind of viral in a way that, like, as more people in your neighborhood buy an electric vehicle, your chances of knowing somebody, if you live in an area that's, let's be honest, that's wealthier, that people can afford electric vehicles more easily, that, is, probably more in a city, more in a suburb, places where electric vehicles are more popular. It's going to kind of spread across the country in kind of a viral manner in terms of how people get exposed to these vehicles. If you live in a small town in a rural area, and it may be a decade before you know somebody who has an electric vehicle, or maybe not. Maybe so it's kind of a it's a contact with people, kind of a viral spread.
Right. I really liked I think your best slide is the supply trajectory slide, is because it reminds me of slides that actually tell you a lot of things at the same time.
Yeah.
Right. There's a whole for one half of the description and a discussion on the one half of the slide, and the other discussion on the other half of the slide.
Yeah.
It's one of the issues that we looked at. Gosh, I think it's probably been over 10 years now, when we started talking about how do you turn over a fleet of vehicles, right? And how long it takes to turn over a fleet of vehicles. And we had estimates about what happens if you sold 100% of your of your fleet was EVs this year.
Yeah.
How long then is it going to take? And we weren't even back then, we weren't even close to that, right? We're still not close to that. It just shows you how long it takes.
Yeah.
To actually build up that fleet, so that, the sales of the new vehicles, so that they become part of the used fleet and be part of the total fleet.
Yeah, exactly. When you finally look at it from that perspective, it really flips the perspective in some ways, in terms of, like, how do we solve again, we still have to solve the barriers for everybody in that curve in order for an EV to make sense for them. But it really puts into perspective how long it's going to take to get EVs into the hands of most Americans.
Yeah.
And when people hear 100% by 2030, they're like, well, I'm not ready for an EV today, and I might not be ready for an EV in 2035. Well, that's okay, because half of the population won't be able to have one yet. There won't be enough for everybody to have one, even in those later dates, because of how long it takes to turn over the fleet. And we really see those consumers who want an EV but can't have them because of that slow turnover. We really want to help, advocate for them.
Greg, did you have anything you wanted to add or ask Chris about?
No, I think he really covered the subject well. So
I think that it's a kind of a good lead in to your story, especially the history of work that you've done on life cycle, because now you're looking at a vehicle, the whole vehicle life, and as well as it's from cradle to grave, right? As we have talked about it for many, many years. Last question, Chris. A couple questions. One, where do hybrids fit in on this?
Yeah, I think hybrids are a good transition. There's a really strong use case for hybrids, I think hybrids work great for most Americans. Right now the incremental cost of a hybrid is fairly small relative to the fuel savings that you'll get. And again, in that one survey question of consumers who weren't looking at a conventional gas vehicle, many of those consumers were willing to cross shop an EV and a hybrid. And I think automakers that maybe can't build as many EVs quite yet, the more of your fleet that you can hybridize, especially in this transition period, those hybrids are going to do a lot better for you than the less efficient gas vehicle that's not a hybrid.
One of the attendees asked a question about, do you have a source for the statement about vehicle ICE and EVs being equivalent in price, comparable vehicles in price within another vehicle cycle?
Yeah, I do. It's the International Council on Clean Transportation has done some really good analysis on that. They put out a study last fall on this, and it really looked at different battery sizes. So as the battery gets bigger, the time for cost parity goes out further. But
it may be related to definitely to the battery size, right?
Yeah, but they found in 2030 up to 300 miles in every vehicle class would be at cost parity, and before 2035 400 miles of range would be at cost parity for all vehicle classes.
Last thing I wanted to talk about a little was the idea of being a fast follower. Some of the manufacturers, FCA in particular, they have a history of being, now they're no longer alone. They're now in Stellantis. So Stellantis now has a European arm, and that they're a much more global company than FCA was. But FCA had this history of being, we'll be fast followers. We'll be able to do this technology thing. It's okay. We'll be able to figure it out. And we'll be, in the meantime, we're going to be selling a lot of these other vehicles because they're more profitable for us. It sounds like you're not quite convinced that being a fast follower for this type of technology is going to be a good plan.
There's a lot of risk in it because you have to get it right. If you there's a learning curve that's not just we can take what everyone else did. You've got to, most automakers go through multiple EV cycles, kind of their first tier EV, and then they'll build their first dedicated platform, and they'll learn from that dedicated platform to build a new, their second generation dedicated platform. And if you stumble, if you don't get it right, if your vehicle isn't competitive, in some of those early generations, if you can't catch up with everyone else, there's an opportunity, there's a chance that you just never catch up. That if you stumble, because this is happening so fast, there may not be a second chance if you stumble.
Very good. Chris, thank you very much for your time and your insight. Really good presentation. You're going to be able to stick around and be part of the other Q&As?
Yep, I'll be around.
Great. That's great. The survey that we did of industry experts, asking them about parity, does not match yours. But we'll talk about that later. All right, Greg, you're up next. Greg Hewling co-founded and serves as director of the Center for Sustainable Systems here at the University of Michigan. His research focuses on the development and application of life cycle models and metrics to enhance the sustainability of products and technology. He has pioneered new methods in life cycle design, life cycle optimization of product replacement, life cycle cost analysis, and life cycle based sustainability assessments ranging from energy analysis and carbon footprints to social indicators. Systems studied include alternative vehicle technology, renewable energy systems such as wind farms, photovoltaics, and biomass electricity, buildings and infrastructure, information technology, food and agriculture systems, household appliances, and packaging alternatives. Greg, you've been a busy guy. Just on a personal note, I met Greg back in the 90s when he first started life cycle analysis, and I remember the first lecture that I went to about life cycle analysis and looking at all the inputs that needed to be generated, and I was overwhelmed by it and how difficult it was going to be. But that's almost 25 years ago, right, Greg?
Mhm.
And, things have changed, and some of this stuff you're going to be talking about, right?
Yes, yes.
All right, Chris. Greg, take it away.
Okay, thanks a lot, Bruce. And yeah, I've been modeling the life cycle impacts of products and technology for 30 years. And but a lot of the focus has been on vehicles. And so I'm really happy to talk about that work and really understand the implications of this EV transition specifically with regard to greenhouse gas emissions, because that is a big motivation for this transition, is to address the climate emergency that we're in. And Vance, so, just context, we are in a climate emergency. We're not on track with regard to moving fast enough on reductions, and the impacts of climate change. We're seeing it with regard to more extreme weather events, droughts, flooding. It's really a motivation for this transition. So I'm going to talk about climate action. I'm going to show the contribution of the transportation sector to carbon emissions. Some of the goals and targets have been talked about already, but then I'll give a short tutorial on life cycle assessment and carbon accounting, and then spend a bulk of the time talking about two recent studies that we've conducted. One with Ford Motor Company comparing ICE and BEVs with regard to greenhouse gas emissions across the powertrains and across vehicle types, sedans, SUVs, and pickups. And then a more recent study where we expand to not only map out the greenhouse gas emissions across the country, but also looking at fueling costs, and something that's very important, particularly in the justice realm for low-income communities, is something called the transportation energy burden. And that's a percentage of one's household income that is spent on vehicle fuels, whether it is gasoline or, in the case of the EV, on charging. So I think everybody's aware of the climate crisis in terms of warming that we're seeing. This is just a map of the United States, and we're already beyond 1.5 C in almost 500 counties in the country. And that's really the threshold where we'll see very adverse effects of climate change. And a thing to point out when we look globally at this, many of the world's poorest are really going to be disproportionately impacted by climate change. They're more vulnerable. They don't have the resources to respond. And we're seeing events in terms of droughts, in terms of flooding. If we look out over the next several decades, these impacts are going to have a huge cost in terms of our economy. So there is an urgency. 1.5 C is the Intergovernmental Panel on Climate Change threshold. And in order to meet that, we need to really cut our carbon emissions by 2030 by 50% and hit net zero by 2050. And you can see over here on the left, the US per capita emissions are quite high, around 17 tons per capita, among the highest. The world average is about 5, so we're over 3 times. And if we want to hit a 1.5 C target, we need to be down in the range of 3 tons per capita. So a huge reduction is required. This is on the right here, the track that we've been on in terms of emissions, and you can see we need a dramatic reduction. And to hit 1.5, to follow the green trajectory, that is very aggressive, and we are not on track. You could see optimistic scenarios based on pledges. So this is critical, and the vehicle sector is really where there's a huge opportunity. The transportation sector is where there's a huge opportunity to have influence. If you look at the United States, the transportation sector is responsible for 27% of the greenhouse gas emissions. And that doesn't even include emissions in the industrial sector to manufacture the car. So it's even greater in terms of its influence. And if we break that down in terms of transportation, light duty vehicles, which is really where we've been focusing today, is about 60% of that 27%. So we've talked about targets. When we look at EV transition, there's national goals, there's OEM goals, there's fleet, private and public sector procurement targets. This is a multi-governmental policy forum for trying to accelerate adoption of EVs, the Electric Vehicle Initiative. And we've talked about this already a bit, so I'm not going to spend too much time, but in terms of market share in sales, here's the US in 2021 at 7%. We have a target to get to 50% by 2030. You could see Europe and China is much further ahead in terms of share of the market and the goals of China. And you can see the goals of Europe coming up to 100% by 2035. If we look at other countries, particularly in Europe, they have much higher sales of EVs. Norway is well over 80%. So much more aggressive in many countries in Europe. And this was mentioned that there's the battery electric vehicle, all battery, and then there's PHEVs, and you could see sales in 2021 in China, a significant number of PHEVs. Here's Europe, almost equal, and then the US. And in terms of specific OEM goals, Ford is 50% global sales by 2030, 100%, which in the EU of sales by 2035, GM 100% by 2035, although that's was really considered more an aspirational goal, not necessarily a firm goal. 6 companies that pledged in COP26 to phase out gas vehicles by 2040, and globally, and by 2035 in leading markets, these companies shown here. So our mission at the Center for Sustainable Systems is to develop system models, methods, and metrics to be able to advance sustainable futures. And we're really interested in the acceleration of high impact sustainability transformations. So the systems we're looking at are buildings, mobility systems, food systems, and these are the levers that impact the sustainability of the system. You have your technology, your design, the enterprise, the supply chains, your policy, your regulations, your incentives, the markets, and then consumer behavior. We focus on assessment, so systems analysis to inform decision-making to accelerate this transformation, specifically the transition we're focused on here is from ICE, the incumbent technology, to an EV alternative technology. And our life cycle analysis then provides information to inform how well that technology is doing, or how well that design is doing, or how well incentives do with regard to total cost of ownership, for example, on vehicles. So when I say life cycle assessment, this is a schematic of a generic life cycle, which starts with raw material acquisition. You have material processing, manufacturing, assembly of vehicles, use, service, and then you have end-of-life management, which can include recycling, remanufacture. And we draw a boundary around the system, and we do an accounting of all the material and energy flows into the system, and then all the outputs in terms of emissions per product. And it's a way to develop metrics to evaluate environmental sustainability performance and see how the impacts distribute across the life cycle. And Bruce was talking about our work in this very early on. We did one of the first comprehensive assessments of a mid-sized vehicle back started in the mid-90s. It took us 3 years to model the life cycle, 20,000 parts and components, where you start out with vehicle assembly and you work back into the systems and the components and where the materials are coming from. And 3 years later, we get a profile like this, which is showing the life cycle energy across material production, manufacturing, and use, and end of life. And here's the total. And you can see 85% of the energy in a mid-sized vehicle, gasoline, was in the use phase. But this is a very useful framework to be able to evaluate alternatives like lightweighting the vehicle, where you could reduce fuel use. If you do it with aluminum, material production could go up because aluminum is more energy intensive. And so this allows you to be able to evaluate alternative strategies for reducing impact. And so we moved from internal combustion engine vehicles to alternative vehicle technologies. This was a study we did with the US China DOE Center, Clean Energy Center, focused on clean vehicles. And this is showing you for a PHEV, this is a volt, the total greenhouse gas emissions. And on the x-axis here is the amount of driving in electric mode. So 0 is all gas, and then you go out to 1, which is all electric. And you can see these lines here showing generally a reduction in emissions as you drive more in electric mode. And the colors of the lines correspond to the different grids in the United States. There are 2 grids in the country, the purple and the turquoise, where the emissions actually go up. And that's because of the composition of the grid. There's heavy coal. And we did this with looking at the China grid, where they have heavy coal, and their emissions would go up with regard to electric mode at the time for this PHEV. So what's really critical in addition to the transition for the vehicle in terms of the powertrain is to decarbonize electricity. And currently in the United States, we're about 20% renewables and about 20% nuclear, which is essentially 0 carbon emissions. We do take into account actually the emissions associated with producing a wind turbine or a photovoltaic, and there's a small amount of emissions associated with a nuclear fuel cycle. So about 40% is close to 0 emissions, but then you could see coal and natural gas. Now these are being reduced as the renewables increase, and you could see wind and hydro solar are the dominant. But we really need to accelerate the deployment of renewable electricity in conjunction with the vehicles. This is our grid in terms of all the resources going into the grid. It's an energy flow. But you could see about 2/3 of the energy is lost as waste heat. So this is a huge inefficiency. This width of this arrow here would be enough to fuel all of Japan's economy. If you look at the life cycle greenhouse gas emissions, taking into account the total cycle, you could see here coal, which is about 1,000 grams per kilowatt hour, so about 2 pounds of emissions per kilowatt hour. Natural gas is about half of that. But then you could see the renewables here, very low in terms of emissions. And we also have storage technology indicated here. And here's nuclear. So the first study I want to talk about is one we did with Ford, where we looked across powertrains, included HEVs and these vehicle types. And we looked geographically at the grid fuel mix. We also took into account temperature effects on fuel economy, both for gas as well as the EVs. We published this, last year. And we were really focusing, the study was focused on pickups, but we went across all of the different vehicle types. And just, key findings, we found that over 50%, 57% lower life cycle greenhouse gas emissions for an ICEV on average across the country when it's replaced with a BEV. And this is, again, across sedan, SUV, and pickup. But there's a greater total tonnage of emission reduction when you go to a larger vehicle size because of the inefficiency. So for pickups, you would actually reduce emissions by 62 tons compared to 40 tons saved with the sedan. An interesting finding when we look at the vehicle cycle, which includes the material production, the manufacturing, and disposal, we actually increase almost double the emissions of a BEV in terms of its manufacturing compared to an ICE or an HEV. And this is due mostly due to the batteries. You can see the battery is here in orange, and this is across sedan, SUV, and pickup. So from a carbon reduction point of view, we're actually going backwards. We're increasing emissions, but over the life cycle, there's a tremendous savings in the use phase. So over the total life cycle, we see this 57% reduction. And if we use 100% emissions of an ICE pickup as an index, these are the actual emissions in grams per CO2 per mile. You could see the reduction, from 100%, you're down to 45%. If you go compare that with a BEV sedan, you're down to 29%. But again, going across each of these types, it's, over 50% reduction. And the payback is less than 2 years. So the ICE is the lighter shade in the colors. The darker is the BEV. And we're talking, again, less than 2 years for each of these. If we look geographically at the distribution, you could see the ICE on the left, the BEV on the right. Blue is lower emissions. So the dark blue is into less than 100 grams of CO2 per mile. So you could see here, very low emissions with the BEV compared to the ICE vehicles. And across counties, we saw consistently lower emissions. There are a few counties that are heavy in coal, and the climate, led to slightly higher emissions. But again, over the country, its majority is significant reduction. And as the grid decarbonizes, these counties will also show net reduction. And we did look at different scenarios for decarbonization of the grid. And we were looking at a new vehicle purchase and looking at its performance over its service life, the total service life. So in the deep decarbonization case, in the time frame we were looking at, there weren't big differences. So in terms of deployment, and this is from NREL, the National Renewable Energy Lab, in terms of we what we looked at. But we did take into account how the grid was decarbonizing and how that affected emissions over the life of the vehicles. So the second study I would like to talk about is expanding and going beyond greenhouse gas emission distribution to look at mapping fuel costs and also energy justice. And the metric we used to explore energy justice was this transportation energy burden. So, in terms of the transition in the environmental perspective, we look at greenhouse gas emission savings. There's also criteria air pollutants, which in many cases will follow greenhouse gases. And then we looked at fuel cost as well. Excuse me. And then we also looked at this transportation energy burden, which is the share of income spent on fuel. So if you look at transportation energy burden across the United States, this is a map. The national population weighted average is 3.6% of a household income is spent on fueling. And this is the current on-road vehicle stock. We consider a low burden to be less than 2%, high burden over 4%. And you could see much of the country is experiencing high burden. And this is particularly a challenge for low income communities and households. So this was the metrics, basically the methodology we used to calculate emission savings, fuel cost savings, burden savings. And I will say we looked at a census tract level, and we looked at local grids in terms of emissions. We took into account driving patterns more locally to put together these maps. And key findings with regard to fuel cost reduction with new BEV adoption, there was about over 50% reduction on average, with 71% of the households seeing over 50% reduction. If you look at, we also looked at new adoption, new ICE adoption, because those vehicles are also getting, compared to the current on-road stock, those vehicles are also improving in terms of fuel economy. There would be a 27% reduction in cost, but only, really nil in terms of households seeing over a 50% reduction. So these are maps showing you the new BEV adoption with regard to energy burden and new ICE adoption. And you could see 1.4 to 2% burdens for new BEV adoption, again, compared to the 3.6% for current on-road stock. And of course, as you go to larger vehicles, the transportation energy burden goes up because they're using more fuel. With regard to the ICE, the new ICE adoption resulted in a 2.3 to 3.4% transportation energy burden. So a significant improvement in reduction with regard to the BEV in terms of reducing the transportation energy burden. This is looking across income levels. So this is 0 to 30% of the average or the area medium income, and then 30 to 60, 60 to 80 going all the way up. But over half of the lowest income households over here in the 0 to 30%, and that's 8.3 million, would still experience high energy transportation energy burdens. And that's looking at home charging. If we look, if at-home charging is not available, which is the case in many cases with regard to low-income households, they may not have garages or be able to they may park on the road, not be able to plug in at a home charger. That goes up to 3/4. And the difference there is the we found the median cost of electricity was 22 cents for public charging compared to 16 cents for home charging. This is a map of the energy burden for the lowest income households. These are concentrated in the Midwest and two states with the highest electricity prices, Hawaii and Alaska, where there's really high energy burdens. And you can see black, we're talking about 10 to 64% of one's household income in that range. Really, showing the unaffordability in terms of owning your own vehicle. The EVs will reduce that burden clearly, but it's just to point out that this still is a significant burden, for low-income households. So with this study, we found again that you get GHG and now fuel cost savings in most of the U.S. populations, with the highest savings in the Pacific and Northeast states. And this is primarily driven by lower carbon electricity grids, high gas prices, with relatively low corresponding electricity prices. 80% of households with high energy burdens that electrify will have high greenhouse gas and fuel savings. But when we look at energy justice, low income households, we need to really look at we need to look at targeted policies to really promote justice in these communities and address mobility needs. So that is subsidizing charging infrastructure. The IRA focuses on charging infrastructure, particularly for Justice 40 communities. Are there strategies to reduce electricity prices? But then we also need to look at other opportunities in terms of enhancing mobility, in terms of low carbon, which is public transit, biking, car sharing. And we did talk about affordability, and we're moving to a study now where we're looking at the total cost of ownership. Clearly, the EVs will reduce the fueling costs, but then there is the affordability, and that's the second project that lists here, where we're doing a regional analysis, looking at the vehicles, and we're beginning another study looking at used cars, which Bruce indicated, 2/3 of purchases of vehicles are used vehicles. And so we're looking at, in that study, from purchasing a vehicle that may be 3 years old or 4 years old, what is the total cost of ownership for that household? And one of the things with EVs that we really haven't talked about in terms of affordability is depreciation. And studies have shown, and actually empirical data shows, that depreciation is greater in the EVs. And partly that might be due to concerns about the battery and range, because you do get degradation to some extent with range. But the other thing to note here, even if you have a degradation in range with regard to these vehicles that have, let's say, 250, 300 mile range, a lot of our driving is, commuting, and much less than the total range of the vehicle. And so if, even if range is somewhat compromised, with age of the vehicle, it still has tremendous utility, and can be beneficial, in terms of low-income communities to have access to vehicles. So, and the other study that we're finishing up right now, we looked at the vehicle, the transition and the reduction in emissions, but we're looking at what is the fleet effect, which we've been talking about. So, we're looking at 50% target sales goal by 2030, which is aggressive when we know the constraints there. But we studied what is the implication of that with regard to carbon emissions. and with regard to their trajectory to reduce carbon emissions by 50% by 2030. And, we're finding, just because of it takes time for the fleet to turn over, we're 1% of the fleet is EV now, that, it's difficult to meet that 50% reduction. And actually, much of the reduction is from reduction of emissions in gasoline vehicles. But if we go out to 2035, we really start to see penetration of the EVs in the fleet, and we get close to meeting the 50% reduction target of IPCC. So I just want to acknowledge sponsors here, Ford, and we're also part of the Responsible Battery Coalition, which is funding our work on total cost of ownership, and we've done a lot of work on optimal charging of vehicles. But I just put up here the publications that of the 2 studies that I presented today, and be happy to answer any questions that you might have at this time. So thank you very much.
Thank you very much, Greg. Very insightful stuff. Got some questions for you. We got some questions from the audience as well.
Great.
When you're in your slide about the transport, one of your early slides about you're looking at transportation versus industry production emissions, by sector, and
Sure.
you're saying that there's also is the transportation section really just about when vehicles are moving?
Correct.
As opposed
So
to
that's the use phase.
the in use.
So right now, with the ICE vehicles, 85% of the emissions and the fuel use is from the use phase. And then you would get another, 10 to 15% would be part of the industrial. So you would allocate, some of this lighter green to transportation to look at it from a life cycle point of view. Just like here, interestingly, but then, here's electricity. So right now it's very small in terms of what electricity is going for transportation. If you look at buildings, for example, they look relatively small here in terms of sectors, but a lot of building emissions are associated with electricity use.
Very good, thank you. One of the things that has happened to manufacturers and suppliers is the kind of a responsibility for sustainability, right, in their supply chains. Have you worked with OEMs and suppliers on these new responsibilities? And is LCA? Would you have to do an LCA for each component?
So we've done a lot of work over the years looking at parts and components and systems, lightweighting vehicles, to provide insight. I mentioned, for example, with aluminum, you could lightweight the vehicle and improve the fuel economy, but some of that gain is offset by the production of aluminum, which is electricity and intensive. Then it depends on where your electricity is coming from. So we have worked with suppliers on material selection, on strategies to decarbonize, and we know right now that the key strategy is electrification in terms of the vehicle. Lightweighting is also important, and as we're adding weight to the vehicles, lightweighting is going to get even more emphasized. But again, with aluminum, which if we're talking about body, is generally coming from primary aluminum, that's much higher in terms of carbon intensity than recycled aluminum. And so we're actually involved in a project called the Clean Sheet Project, where we look at bringing aluminum back and steel, the certain types of steels, high strength steels, bringing them back to make new body. Again, that would reduce the emissions because of emissions of secondary materials are much less than primary. But yeah, the OEMs, they are, ultimately responsible in terms of the design, but all of, the suppliers are really heavily focused on carbon. They are setting science-based targets to reduce their emissions, scope 1, scope 2. And Ford has actually set goals in terms of its scope 3 emissions. So emissions associated with the products they sell. And suppliers are doing the same. They're looking at their own emissions, but also they're looking at strategies to reduce emissions associated with further upstream in their supply chain. So this is very important.
Very good, thank you. Now, one of our, I think for our China conference last November, we had a researcher from China who was speaking about emissions from the Chinese emission story. And one of the questions that came up then, and one I think also applies to you, do you use marginal or average CO2 emissions from power plants?
So in terms of looking at the vehicles today, since we have a relatively small share of the market is electric vehicles, I think we could use average emissions. Now, we did in our analysis of the work with Ford, we looked at the implications of using marginal emission factors and average emission factors, and there weren't large differences. But as we have more deployment of EVs, I think then it's going to be very important to look at when do we charge these vehicles. And we did actually another study with the Responsible Battery Coalition of optimal charging, because the grid is there's an average over the year, over the day. But if you look on an hourly basis, you have peaking plants and you have base load plants. And so when you charge your vehicle, will have implications with regard to the grid. So we have looked at that, and I think it's going to be very important for us, particularly as we deploy more renewables and you have this intermittency or the variability in terms of those clean assets. We want to be able to smart charge vehicles so that we could utilize that clean electricity and minimize the amount of storage we need to have. Now, that's going to add another layer of complexity. We need to put in place charging infrastructure, but it's also when are we going to charge? And there's issues as well with regard to the capacity of the infrastructure. So we're talking about distribution in terms of local distribution and transformers. And
right.
So we're really, there's much more to this story as we move forward in this transition of complexity. But we can do it, and we need to do it.
Yeah, very good. Chris, feel free to jump in if you have anything you want to add on these questions.
Greg, I did have one comment about towards the end, you mentioned lower depreciation or higher depreciation for EVs. Have you guys actually looked at that specifically, or?
Yeah, we're starting to look at that, but some of we've looked at other studies that are out there or tools that are out there. So, you could look at, Blue Book and where they're actually estimating, what the used vehicle costs are, and it consistently shows that there is a bit higher depreciation for the used vehicles, which I think from the justice point of view or the affordability and access of the used car market, that's important, and that's, will help. But I think you're probably going to say, well, there's such a scarcity of these vehicles, you wouldn't expect to see that kind of higher depreciation.
I know I was going to comment on the research that I've done on this subject, and
Okay,
what we found is that when you adjust for the incentives that are available on those vehicles, so a lot of times those studies just look at MSRP versus the used vehicle price, but that
Okay.
MSRP isn't what consumers are actually paying for that vehicle because they're getting a large, often getting a large tax credit for that vehicle. When
right.
you adjust for that tax credit that's available on the vehicle, that difference disappears.
Okay,
There was another, and the other factor is range. So we found there was a big difference in the depreciation of vehicles with less than 200 miles of range versus vehicles with over 200 miles of range. So there's kind of like a tipping point that once you get over 200 miles of range, the EVs tend to hold their value better than the older EVs that had lower range, which just their values.
yeah, because their utility is.
Yeah, their utility.
compromised. Yeah, so this total cost of ownership study, we are taking into account federal incentives, more local incentives. We're looking at rebates for charging infrastructure. We're taking into account the cost for fueling. So, with EVs, you could reduce your time spent on fueling. And yeah, I appreciate what you're saying, but we are going to be publishing that, and then we're turning to the used vehicles next.
Great.
Greg, are you guys, have you looked at the eRIN credits? So this is something that a renewable fuel standard that the EPA has figured out. EVs are charged from depending on how they're sourced, where the electricity is sourced. So you have eRIN credits that can have impact on EV sales, because these are credits that, for example, if Ford wanted to generate electricity for charging using renewable fuel, they would get this eRIN credit. And it could be, they could use it themselves for their credit emissions credits. But it's something that it's not in the law yet, I don't think, but I think it's getting close to being part of the law. Have you guys looked into that at all?
We have not.
Okay. Yeah, so
there's
could be another input for
right. Yeah.
Chris, have you heard about this?
I'm familiar with it, or at least like a little bit. I don't know all the details of how exactly it will work, and I know there's still a lot of kind of argument back and forth in the comment period for exactly how this will end up being finalized.
Yeah. In some ways, it kind of reminds me of the e-fuels story, where if I generate something with renewable energy, do I get credit for that in some way? Which is what I think the Europeans are trying to argue. European manufacturers are trying to argue that if we generate gasoline or through renewable process, we should get credit for that, and therefore we do not need to have the 2035 story where there would be no EV, no gas vehicles sold any longer in Europe. Greg, have you been following that?
I'm aware from a life cycle point of view of the controversy about e-fuels and the benefits of that. It's what's challenging here is we need to look at the supply of the fuels as well, and electricity. And we need to also look at how these vehicles are produced. And so, the OEMs are involved in power purchase agreements, or, to get clean electricity to reduce that footprint associated with the production of the vehicle that I talked about. And then, in terms of e-fuels, that there's a lot of if we're talking about, I mean, there's biofuels, but then there's looking at synthetics and even, using hydrogen, that, really complicates, the decarbonization. But I would, I think we need to be fully aggressive on electrification in terms of strategy here. And, and I don't know what role. I'd be interested in both of your views in terms of PHEV, what role that could play in the transition before we, go to all battery electric. But there could be some opportunities to look at for PHEVs in reducing carbon intensity of the fuels could be beneficial, before we get our infrastructure in place.
Yeah, we were thinking about that as a way of, especially for the vehicles that are ICE vehicles. If you get those vehicles to be fueled with e-fuels, meaning fuels that were generated through renewable sources, that would be a really nice way of dealing with it. But when the manufacturers start talking about using it to extend the life of ICE vehicles beyond 2035 and beyond that, it becomes a really questionable story, right? Because, just because what you mentioned, Greg, from the United Nations report, the clock is ticking.
Right.
You can't let this story go on indefinitely and say, okay, it's ICE vehicles forever. There are going to be some ICE vehicles that are going to last a really long time, but
Right.
you can't have 50% of the fleet be ICE vehicles.
Right.
At that point.
Right. And then we haven't talked at all about the oil industry and its role here, right? They're the ones that are providing the liquid vehicles, and how aggressive are they in terms of this energy transition? And I think we could say fairly that they haven't. The OEMs are moving. I'd say the oil industry is much slower in terms of a transition to clean energy, and really looking at IPCC targets for reduction. I think there's some burden there that needs to go to the oil industry as well.
Yeah.
I'll just chime in very briefly on PHEVs. I think they're going to be, I absolutely think there's a place for them, but there are bigger challenges with PHEVs in some ways, because one, consumers just really don't fully understand them. And even when they do, they kind of think of them as being fairly complex technology. And so a lot of people who would consider a PHEV might just go buy a BEV anyway. They don't actually ever achieve cost parity. They're always going to be more expensive than gasoline vehicles, and soon they'll be more expensive than BEVs. At some point, BEVs will become cheaper than PHEVs in the not too distant future. So I think there's use cases, especially on towing vehicles. I'm really excited to see what Ram does with their range extended EV pickup truck. I think that could be a solution for, with range extenders on towing vehicles, could be a really useful segment for PHEVs, but I just don't see them being a big chunk of the electrified vehicle sales, just because of that.
We only have one car in our household, my wife and I, and it's a PHEV Ford Escape. And we do a lot of gardening, and we haul some things, and it's like the ideal vehicle, but driving here is all electric. But we do go up north, and so that's where we appreciate having the gas option. But the other thing we haven't talked about is, the battery is expensive. It's resource intensive. There's a lot of impacts from mining lithium. you know, in terms of water availability, particularly in you know, some of the countries that are supplying now. The vehicle capacity, the 200-mile, 300-mile range we're talking about is not what is needed for commuting. And so there's this excess capacity that we're carrying around that's adding weight and reducing fuel economy, you know, to give us that full range. And I think there's an opportunity to have, you know, lower range vehicles, you know, for commuting, and really think about a little more differentiation there in terms of the vehicle. Not only, you know, it could help with regard to cost, but could really help with regard to environmental impact. But I don't know, we're, you know, I think there is obviously that, you know, this range anxiety and then, you know, need to extend range, but I think differentiation could actually help with regard to cost and environmental impact.
Very good. Thanks, Greg. Thanks, Chris. I think we're going to take a break now. Okay. All right. I want to start off this section of the conference looking at the results from a survey that we've done within the last month or so, looking at EV challenges and opportunities. It's, as usual, our sponsors are our affiliate sponsors that help provide the funding for our research. Again, we thank them. So it's a survey of experts. We have a database of about close to 1,000 people in the from automotive manufacturers, suppliers, government, NGOs, academia, and consulting. And we ask them from time to time for their predictions on a variety of U.S. EV challenges and opportunities, including the future market, manufacturing, vehicle safety, vehicle charging, and government support. Here are the surveys that we're showing now have been completed just in March and April of this year. So you look at the demographics, 20% manufacturers, 35% parts suppliers and service suppliers, and 45% industry experts. They range also in title, CEOs and et cetera at 24%, chief engineers, chief technology directors at 22, managers at 19. So it's a good representation of the respondents. One of the things that we're not going to talk about today, but that we offer our affiliates is that we weight all the responses by their level of confidence. So we have a group of questions. We ask them how confident were they in answering those in their responses for those questions. They rate it on a 1 to 5 scale, and that gets put into an analysis that looks at that weights their and changes the effects of their responses on a particular question or a set of questions. So we have a variety of market overview questions. Percentage of new vehicle fleet. What do you think are the top 5 aspects of customers' desire in an electric vehicle, et cetera. We'll go over these one by one to show you what we found out. So in terms of percentage of U.S. EV sales, a little underwhelming compared to what Chris was talking about, and also what the government wants. You'll see that 12% by 2025, 26% by 2030, 41% by 2035. You know, the government was China hoping for that they're going to get 50% by 2030. So our respondents are a little less optimistic about EV sales. When you ask them about the top 5 aspects consumers desire for in an EV, range is number 1, followed closely as usual. Usually number 1 is price, followed by time to charge, battery life, and then into the typical things that most people look at when they look at a new car: vehicle segment and vehicle design and performance. as you can see, the issues having to do with range and batteries, it's all about batteries, right? Battery range, time to charge, battery life. That has a lot to do with what they are looking for. This is from experts' view of what consumers think. Now, Chris was talking about, he was actually interviewing, and they were interviewing and surveying people who are making these decisions. But so it'd be interesting to get his perspective on this as well. Are government subsidies enough to support consumer EV purchases over the next 10 years? A little uncertainty here. They're not quite convinced that this is going to be the consumer EV purchase support is going to be enough that the government subsidies are giving. When will comparable EVs and ICE vehicles be the same price? Well, the average year is 2033, which is very different from what Chris is talking about. This is the same response we received in 2020 when we asked this same question. It could be our sample. It could be our sample of experts heavily focused on the auto industry and have their own views about. Obviously, they have they're feeling less that there's going to be less EVs on the road in the next 10, 15 years compared to what others are saying right now. And this kind of reflects that in terms of pricing for comparable pricing between EVs and ICEs. Now, in terms of EV manufacturing, we're looking at how long will it take for the majority of traditional manufacturers to be profitable selling EVs. Well, definitely looks like pretty good. Looks pretty good within 6 to 10, within 1 to 10 years. But 10 years is a long time. Chris made that point. I was a very good one about how manufacturers who are doing and suppliers who are working in areas of developing new technologies will get some tax credits for that. Then that will actually help support their profitability. Now, over the next 10 years, how difficult will it be for manufacturers and suppliers to meet their environmental sustainability goals for their supply chains? Yeah, pretty difficult, they're saying. They're seeing that as one of the big challenges. Again, this is something that Greg was talking about in terms of the life cycle analysis and sustainability goals for the future. Not an easy process, not an easy thing to do, according to our experts. Same was true about the material supply chains for EV batteries. They also expect this to be a difficult thing for the manufacturers. Not that it's something they can't do, but it's going to be pretty difficult for them, at least moderately difficult for at least 58% of the respondents. One of the other issues with having to do with EVs has to do with how is it going to affect workers? We looked at that the possibility of that most of the studies talk about reducing the number of workers. But we also wanted to see if there was going to be any kind of increases. Well, our experts really didn't feel there's going to be very many increases in terms of workers in the transition to EVs. They're pretty uncertain about how big that decrease is going to be. The average, I think, came out to be in that 11 to 15% decrease in workers. Significant amount of workers, fewer workers needed to create, to develop, and produce EVs. We also looked at charging. Lots of issues related to charging. When you look at when you look at charging at home and charging away from home, where they were talking about by 2025, 20% of charging would be away from home and 77% would be at home. And by 2030, away increases and home decreases a little bit. I was unsure about how to take this. It could be just that because there's going to be so many more EVs on the road that it'll be easier to charge than that at home, or just because of the volume of EVs. And there will be there will be more people who will not be able to charge at home who have an EV, and then will actually be charging away from home. In terms of OEMs, charging percentage of OEMs owning charging stations, I was a little stumped by this one as well. Whereas by 2025, they're saying 25% of companies will own their own charging station, but by 2030, it's actually decreases. I'm not sure why that is. That's the one I was a little stumped by. Out of in every survey, there's always a question, and then you get a response, and you go, I don't know what this means. And this is this is the one for this survey for me. When will most of the charging station companies, public or private, be profitable? Here you're looking at the range from about 2026 to 2031. There'll be, and this will be the time where there'll be so many more chargers and charging stations and chargers developed and put out there, and probably more business models about how to do this successfully. How is it likely that the traditional oil and gas companies will expand their business to include electric vehicle charging services? Again, they're seeing this as something that's pretty likely that they will go into this. We have not really seen this yet. This is not really something that we see that the company's getting into. It could be the e-fuel story, but it's not really the electric vehicle charging services. Having said that, there has to be a transition for the people who work in oil and gas companies. They have a tremendous large amount of people who work in these companies, and a tremendous amount of profit generated from these companies, and transitioning them into something that would be profitable for them in the future. I think it has to be on the radar screen, I think, for some people, especially from a government side. Also looked at EV safety. How often in the last year have you heard news of electric vehicles safety problems? Well, as you can see, it happens. We talked a little bit about this in the first session today, where we're looking at talking about safety. But this kind of tells you that these people are seeing it pretty frequently. Do they see battery fires as a particular safety challenge for electric vehicles? That's definitely pretty much a yes, in terms of what is the number one safety challenge for electric vehicles. I guess it would be battery fires. What we've learned over time, just over the few years that EVs have been on the road, is that certain types of batteries are less likely to start fires or catch on fire, which would be the LFP batteries compared to the NMC batteries. So we're actually seeing the introduction of LFP batteries into the fleets. Many of the manufacturers are already using them or considering them. Many manufacturers in China are using them, just probably for the safety value, or because they just don't. LFP tends not to have the range, the power that an NMC battery has, but it also has different materials. And maybe the certain materials are easier to get, and so they're looking at other ways of reducing cost, and that could be one way of doing it. The safety issues are connected to that, and also the overall cost of the vehicle. It can be reduced because of that, though range goes down a bit. We also looked at issues of ESG and electric vehicles. Well, when you look at how successful EV battery recycling will be in 2030, it's a little mixed bag on this. They generally think it's going to be successful, but there's some uncertainty there about whether they think it'll be successful by 2030. One reason could be volume. When you're looking at what kinds of how many vehicles are actually going to be recycled and how many batteries are going to be recycled by that. Now, EV battery recycling is one thing. Then there's smaller battery recycling that could be part of the story, but it's really the EV batteries that are connected. And as I said in my introductory talk, there's a lot of money being spent on EV battery recycling, and a number of companies, 5 major companies that we showed were actually focusing on doing this and are connected directly sometimes to new battery plants from suppliers or battery plants from manufacturers that are in process right now. So the manufacturers see this as something that they learn this from aluminum and steel and iron, that you can recycle these and get a good product out and save lots of money. Now, there's also the energy that's used for that recycling, that's part of the process, and I think Greg was talking about that as well. So yeah, it's definitely one of the issues for the future, but it also helps reduce the amount of mining that you have to do to generate the materials for the batteries, which is significant. When do you think EV battery recycling, public-private, will be profitable? Wow, very, very uncertain here in terms of profitability. Going out until from 2029 and later for profitability, at least from our experts. Approximately what year do you think nearly all the electricity from the U.S. power plants will be carbon free? Well, they make it to the 2050 deadline of carbon emissions but they're not. Things are not happening any sooner than that. This is, of course, the average year that comes up in the estimates. How successful will U.S. government policies be over the next 10 years in helping the U.S. auto industry transition to EVs? Now, they feel that government policies are going to be pretty successful in supporting the industry. But how about supporting the consumers? This is government. I think this was for the government. This one's for consumers. How much is it going to support consumers? Not quite as successful as they will be for the manufacturers, but definitely supportive. So, in summary, the U.S. EV market will grow significantly over the next 7 years, but not to the level the government would like. After meeting EV-specific needs for battery range, battery life, recharge time, experts think EV buyers will focus on price, vehicle segment, vehicle design, and performance. And government support for purchasing EVs will be helpful over the next 10 years, but it may not be enough support to drive the levels of EV ownership they hope for, mostly because the cost of an EV and comparable EV ICE vehicles will not be the same till around 2033. In terms of manufacturing, though some experts think OEM EV profitability can happen within the next 5 years, most respondents think it will take 6 to 10 plus years. And over the next 10 years, OEM and supplier sustainability goals and EV material supply challenges will both be difficult to meet and to overcome. Experts do about how much of a decrease will occur. In terms of charging, 2/3 of the experts think the EV charging will take place at home by 2025, and by 2030, they see this decreasing only slightly, which tells you a lot about the types of people who are buying EVs. These are people who have a way to charge at home. Though 40% of the experts think that charging station companies will be profitable within 3 to 5 years, 67% think they will be profitable within 3 to 8 years. And experts also think that traditional oil companies and gas companies will expand their businesses into EV charging services. In terms of safety, nearly all the experts have heard of safety issues with EVs occasionally or frequently, but they are uncertain about how much EV safety issues will affect purchase behavior. They see battery fires as the serious safety challenge for EVs. For ESG, though slightly over half the experts think EV recycling will be successful by 2030, the other half are not so sure. They see recycling beginning to be profitable by the end of the decade. They see power plants being carbon-free by 2047, just in time for the global warming deadline. And over the next 10 years, they see government policies helping the industry more than consumers, which seems to fit the administration goals of developing local supply chains in the short term. So that's all I have to talk about in terms of this story. Questions from the audience? The question has to do with the range issue for EVs that the experts were talking about, and has that changed over time? We've talked about a lot today about maybe some people don't need as much range as they do, and there's nothing in this survey that we never really asked them anything about if we've seen that change over time, and we haven't asked this question before, so we haven't seen that change over time. But it is something that that is part of the discussion. What we've seen, some of the research that I've seen on the topic had to do with manufacturers. I mean, people who were buying EVs were also keeping their gas vehicles. So they're actually increasing their fleet, and increasing the fleet of vehicles, kind of like covering themselves so that they actually have what they need. In most vehicles, most EVs are luxury buys. And so these are luxury buyers. And this is kind of the market that we're in right now for EVs. There are some EVs that are less expensive, but there's fewer of them. Most EVs are quite expensive. And so that we really can't get a sense of that until we get more of those vehicles into the market, and maybe some of those vehicles get into the used market more, and we'll be able to make an assessment of that. Good question. Good question. Other questions? Yeah. The question has to do with government regulations for safety on EVs, and in particular for thermal runaways and battery fires. Right. That's what all it comes down to. And in the past, what we've seen in these situations is the government has been reluctant to jump in immediately in these stories. It isn't just EVs. They're reluctant to jump in on a lot of things. If you look at what happens with AVs, in automated vehicles, there are very few regulations out there. The government they're reluctant because they don't know enough to actually make a call on these things. One of the things that happened, and this is true because of the Chevy Bolt fires, where there were a number of these fires that occurred, and Chevy paid for all those vehicles to be either the batteries to be replaced or the vehicles to be replaced. So when the government sees the manufacturers quote doing the right thing, then they might say, well, we don't need to regulate this, especially if there are other brands that are not having those problems, right? If there's one brand that's having a problem and others are not, they go, well, maybe that's their issue as opposed to our issue. But I think also that they are very reluctant to do things unless they have loads of data. But in particular, you start seeing things happen if people die. If there are people dying in car fires, then it's a whole nother story. And that sometimes you see that become one of the prime movers to get for the government to actually do something. That you see, for example, in AVs, I don't think anybody, well, we had one person die from an AV accident during testing that I know of. So we don't see a lot. We see the vehicles themselves crash themselves and kill people. That's their drivers, kind of being part of the problem. So, yeah, so that's one of the issues that's, I think, the reasoning behind that. Yeah.
Yeah, I'll jump in here for a second, Bruce, too. Yeah, I think the existing NHTSA safety recall regulations seem to so far be working pretty well. Automakers have been pretty proactive about trying to catch these issues early, fix them quickly. I think the Chevy Bolt recall situation was a wake-up call for the industry. That was an expensive mistake, but Chevy did the right thing. They fixed things quickly. Overall, I don't see EV battery fires being a significantly larger issue than vehicle fires have been in the past. We continue to see it seems like every 3 to 6 months we get a major, if not more frequently, a major recall for a gasoline vehicle that's having fire issues. As more electronics are being put on these vehicles, there are more things that can spark a fire, and that is a challenge regardless of the powertrain. But I don't know at this point that there's enough evidence that we need specific additional regulations for EV batteries.
Yeah. Thanks, Chris. So Chris, it was more of a comment saying that because of the publicity of EV fires is much higher than anything that we hear about for ICE fires, and because of that, it has a more of a dramatic effect. He was arguing that on the public compared to ICE fires. And
yeah, that can definitely be a challenge, especially when there are certainly elements within society that would rather not see EVs be broadly adopted, that stand to profit from the status quo. And so every time an EV catches on fire, somebody catches it on video, it's gonna spread. That fire will spread across certain parts of the internet, and it is that perception issue is definitely a challenge, which I think is part of the reason why automakers work so hard, are really paying very close attention. And any battery fire issue, you saw it with the Ford Lightning. Ford had one issue. They very quickly shut down production, went in, really dug deep, tried to figure out where that came from, what happened, and diagnose those problems and fix them very early on before they can become more widespread problems.
I think probably in terms of safety issues, I think the gold standard was set probably by Ford with the Explorer, with the rollovers, and they just replaced all the tires on every Explorer. This was when Explorer was selling, 400,000 vehicles a year. And this was the way you deal with recalls, right? You deal with it, and you deal with it right, and you do it fast, and you don't deny, and it makes a huge difference, because one would think that no one would ever buy another Chevy Bolt because of this, but that's not the case. It's not the case at all. But it showed that GM was doing the right thing. And I don't think anybody died. That's that's always a big deal. It's always a big, that will get the government going when people start dying. So I think I'm going to cut my Q&A off here now and introduce Brandon Boyle from Roland Berger. Brandon, he's a senior partner and a member of Roland Berger's North American management team. He has over 15 years of experience working with clients on business strategy and transformation topics across a range of industries, including automotive, chemicals and energy, and financial services. He's currently focused on building Roland Berger's automotive supplier business in Detroit. Prior to joining Roland Berger in 2010, he was part of the strategy practices of a large US-based manufacturing consultancy that will not be named, I guess. He studied electrical engineering and at Oakland University and holds an MBA from the U of M Ross School of Business. Well, welcome, Brandon.
Thanks a lot, Bruce. Yeah, every time I hear that intro, and I appreciate it, it's I realize that we need to update our website because that was over 7 years ago, because I now have over 22 years experience, and I'm actually leading the North America automotive practice now. For
well done.
So no, yeah. So but thanks a lot for that introduction. I really appreciate it.
You can update it you've updated it on the fly here.
Yeah, exactly. This is a presentation that I've had the opportunity to share a couple times across the industry, and I've really found that people tend to like it because they've kind of seen all of these things that I'm going to talk about today happening maybe in isolation, but they haven't really seen all of it kind of brought together to really think through what the broader implications of all of these kind of micro things happening within the economy. So the title of the study is a little bit provocative, The End of Globalization, and it's meant to be a bit provocative because I think we are, like I mentioned, seeing a lot of new things. We're seeing much higher volatility and unpredictability in the industry. Not only our industry, but across the industry. We're seeing it in geopolitics and so forth. And so I thought that it would be good to kind of challenge our first principle thinking on what really underpins globalization and where are we really headed. In order to answer that question, I think we need to first start and think about what enabled globalization to get structured, really kind of starting in the early 80s. And you really had kind of two systems working together. You had the capitalistic construct, and then you had the construct that was more focused on economic development. And while the end goal or the result of these were meant to be very different, they worked together because they were aligned. And that global cooperation provided, for the capitalistic construct, access to low labor markets. It also provided stable and predictable growth and much lower volatility, but it also gave China and other countries the opportunity to grow and develop. So really the two pieces worked together, even though the goals of them were very different. And from that, like I mentioned, we saw in the industry pretty steady growth. So over that period, we saw a 7 to 8% growth and reasonable profitability. 7% in this industry is actually viewed as strong profitability, but that 7% really enabled many things to happen. It enabled long supply chains to be developed, which was very important to further driving cost out. And, that kind of goes again with the capitalistic construct. It enabled global organizations to be set up. So you saw a lot more organizations moving from a centralized either, US or European to really global setups. And third, we saw a lot more global sharing and best practices, and then new technologies really being developed in all of those markets. So this is really what we're considering the golden age of automotive. And of course, the last couple of years have really kind of put that system into question, right? Because we've had pretty significant declines in volume, and we also saw a huge impact on profitability. And whether that was, the result of COVID and some of the shutdowns, which obviously had pretty big impact, whether that's the chip shortage and the ability to stay up and manage production, whether that's, different raw material crisis that were kind of resulting in that, or if we even look at the war in Ukraine, right, that upended an entire wire harness part of the value chain, which obviously had pretty large implications on the industry at certain points. Specifically, anyone that was doing manufacturing or assembly in Europe. So clearly, these issues then raise kind of this question of, when will the auto industry go back to the golden age? I mean, this is always, anytime we have any of these major kind of shocks to the system, the industry and industry leaders are asking us, what is our view on when it's going to return? And so when we started really diving into that, we came to the conclusion that we're not. We're actually going to be entering a new world order. And that new world order can be characterized in many ways. But first, if we think about new paradigms in world leadership, right? All of the economic indicators, which suggest that China not only economically is going to be one of the leads, but also potentially in currency. It's a big topic. We have the divergence in regional agendas. Really, we're seeing the split between U.S. and China, which clearly has become the case. And if you think about, many of the statements that Xi Jinping has made over the last few months, it's really been about, China becoming economic leader, about being a technology leader, and being kind of independent in some ways. Which obviously breaks that construct in the agreement to a certain extent that we had before, which was really about that labor arbitrage. And then, of course, climate change has become a major topic across the industry, which we'll get more into momentarily. So these are really the three main things. And now I'm going to step into kind of what are then the characteristics of each of those. And if you think about them, we see it in three ways. We see that there's this increasing nationalism. We're seeing increased volatility. And then, as I mentioned, ESG is now becoming a table stake in the industry. So increasing nationalism is really kind of manifesting a couple of ways, right? We're having this increased populism. So you're seeing non-traditional politicians being elected into office, driving very different messaging than what you would historically have heard from a more, characterized as a more standard politician or a career politician, which has obviously been a bit more abrasive in kind of how they manage things. But at the same time, we've seen this rise of, nationalistic or deep globalization policy. So a lot more protectionism. We've seen a rise in tariffs. We obviously saw, even NAFTA being challenged during Trump's administration, and now stronger tariffs with China. But then obviously the biggest and most interesting one really being the IRA, right? The IRA was really designed around kind of energy security, but it clearly had major implications on the auto industry. And we think, this is a really good or a very interesting one, because if you think about everything that we've been reading about, battery manufacturing and that coming into the US and electrification just generally, we see three major policies that are within the IRA that really are all in support of that. And I want to kind of highlight one of them, which is this 45X advanced manufacturing tax credit. And why is it really supporting, or why are we seeing such a growing interest in battery manufacturing in the US? And what you can see here is, if you look at the local NCM cost at $121 per kilowatt hour versus what it had been in China, which is closer to $92. And then what the ultimate benefit is from the IRA, and how much that actually puts the US in a competitive position, it's significant. And the thing is that if you even take it a step further and look at local LFP, this number is even lower. And so this is where, it's been very interesting over the last, I would say, month or so, where we've seen major announcements that have gone kind of in interesting ways, right? Ford was the first one where it was very declarative prior to IRA that they were going to do their LFP partnership with CATL. It was going to be a JV. And then post IRA, it shifted to a fully owned Ford plant with then a kickback to China. Now, there's still some questions whether that is going to be supported within this policy or not. There are very clearly different views within the government on how that should go. Some of the extreme measures are they get 0% of the tax credit. More conservative views would be that we maybe just deduct the 12% that would go over to Chinese-owned companies. But you're seeing very different views. And then what you've seen is, the Koreans, who really have been behind on the LFP, on an LFP basis, making pretty significant announcements in advancing and putting new production into the US. So LG just actually announced, I think, 2 new LFP plants in Arizona, one that's going to be focused on serving ESS, and then one that's going to be probably focused on more of the mobility markets. So guys that have typically not been in that space or very good in that technology are now seeing that as an opportunity and maybe even a location where they can sell and export sell. So really, really a huge impact on the industry and how we think the value chain is going to be shaped. We've also seen kind of this split in data between US and the rest of the world, really based on this IP and data sharing. So that's had big impacts on the semiconductor. It's had impact on data ownership and storage, but also on software and where it's developed and controlled, right? So this is becoming a very big topic, and obviously will also have fairly significant implications for the auto industry as we think about serving each of these sets of markets. If we think about what each of the major powers are really trying to strive for, so I think, the US not only is looking for kind of energy independence, but also the rare earth metals, right? So this has become a huge topic on the Hill because they recognize that whether we're making batteries, whether we're making motors, whether we're making electronics, the value chain is still heavily dependent on China. I think permanent magnets are one of the great examples where I think over 50% of the supply comes from outside of China, but I believe over 90% of the battery or magnet production actually happens in China, which obviously creates some pretty significant concerns on national security. So this is where we've been seeing quite a bit of an uptick in policy that helps to drive more development in the US, whether it's in mining, whether it's in production of some of these and processing of some of these materials, which I think we're going to see a lot more of. Obviously, Europe has been very focused on, thinking through energy independence, the reliance on Russia, which had been strategic in the past, to try to probably make things be more collaborative between the two countries, now has become a greater source of contention. And this is where, at times we've been a little bit more, slow on the uptick of fuel cell and some of these other technologies, where this is really being brought back onto the table, as well as, topics like nuclear, which really seems to go back and forth. But all of these topics are kind of being revisited to really think about that energy security. And then the same thing on oil and gas, where if you look at the #1 consumer and importer of oil and gas today, is clearly China. And so for them, it's going to be very important from their national security standpoint to start to move a bit away from that. And that's also part of the rationale that many believe is why, they are pushing so hard on EV. And where we need to, if we're going to keep up technologically, meaning the Western world, need to continue to push on that in order to stay on track and on pace with the development there. So really interesting things if you kind of look at it from a macroeconomic standpoint and geopolitical standpoint on really how and why things are evolving the way that they are. And then, of course, we talk about increased volatility, whether that's the geopolitical tensions, which we talked about. We've also had, this increase in irrational behavior, we'll call it. And then obviously the frequency of natural disasters has really been upticking since we've been seeing more and more concern about global climate change. And here are just some of the examples, actually in just the last couple of years. And on here you can see a number of them, whether it's geopolitical, whether I mentioned more rational behavior, or it's a natural disaster. It's having real world implications on cost and our ability to manufacture and have globalization work, right? Because a lot of it was that freight was fairly inexpensive on a per unit basis, but now when we're seeing these huge price upticks, it starts to kind of bring the scales of the labor difference and transportation differences. They're starting to balance a bit more, which changes how you think about things. And then if we look at the kind of irrational behavior, if we think about the lockdowns that were happening across China and all of the major cities, really that zero COVID policy and the implications, it was pretty significant, right? We saw huge declines in car sales. We saw obviously waiting times in ports and manufacturing being pretty hit hard. And so, this question really was raised quite a bit, and where you started to see quite a bit of protest, and why I think the government was fairly quick to turn it once they saw the tides turning. This is just another point on how we see different governments and the people, and how there's always a fine line, and how that piece is kind of balanced within the regions. The third thing, ESG is a table stake. This is where we're really seeing increased emission requirements increasing across the different regions and governments, sustainability requirements happening within organizations. And then there's a kind of a social piece to it as well, as consumers continue to push for that. So if we look at actual regulations, there's quite a bit of regulation that's already been set in place. There's a bunch of regulation that is confirmed and soon to be upcoming. And then there's still quite a bit that's happening or under discussion. And this list, every day continues to grow. If we then take it a step further and look at actual companies, we're seeing that all of the major OEMs are putting pretty hard lines in the sand on what they're looking to achieve in scope 1 and 2. By, usually it's the 2030, 2035 timeframe, so pretty aggressive, getting to pretty high reductions there. But the more impactful piece is really going to be on the scope 3, because that's when it's really outside of the full control of the OEMs on their own, because it's really dependent on the supply base and then the suppliers, so tier 1, tier 2, tier 3, on working together to help drive these emissions or consumption of CO2 down. So this is really going to be interesting in how each of the suppliers work towards this, and OEMs, and how this actually changes strategy, how it changes footprint, how it changes how they think about really manufacturing and energy together. So what are then really the implications for the industry? So we talked a lot about all of the things that are happening, and we believe that it's going to have implications not only on products, but also the technologies, specifically by region. So actually some divergence in how products and what products will be developed where. We believe that the supply chains are going to continue to be fairly complex and difficult to manage. And third, we think global footprint strategies are going to continue to be challenging, and people are going to need to think about that differently than they have. So literally first principle thinking on all the things that we believe to be true historically, really pushing ourselves to think if we have to challenge those base assumptions and think differently. So if we look at technological divergence, I think a great or an interesting example is kind of on this point that I was mentioning on the motors, with the permanent magnets, which is one of the key rare earth materials, and whether or not we're the U.S. or in Europe are able to figure out a way to get around most of that supply coming from China. And what we're seeing is that there are alternative motor technologies being developed without magnets. And then other regions are more focused on, how can we bring more production of those materials into the U.S. And so we're seeing that likely could lead to some divergence. And the bigger one is probably going to be on the power electronics or the inverter, because the CHIPS Act really has or is putting a lot of pressure on U.S. and European companies and being able to export the technology of silicon carbide and earlier on gallium nitride, which are really the major advancements in the power modules that would go into these products, the inverter products, which could mean that there becomes a bifurcation of the technology that's actually developed in each of the markets, as China doesn't really have any of that technology today. So here's a clear example of where things may diverge in how you think about which products, how it develops, and also the value chains for those. Another one I think is going to be interesting and to watch is going to be how software is developed and those different ecosystems are developing, because really you see the rest of the world kind of focused on OEMs or suppliers kind of driving that, with a whole set of other companies supporting that, with the China really being set up with a lot more of a hard line or kind of the wall between what can cross borders. So we're really seeing that the different ecosystem of software players is going to change, with once again fundamentally changes the product, how you think about development, where it happens, and how you can actually translate that technology across different end markets. As I mentioned, supply chains are going to continue to be difficult to manage, right? The supply chains are being stretched. They're really, becoming more and more difficult to manage, especially with the number of shocks to the system. And then as we see these sustainability and CO2 requirements continue to increase, we think that's just another complexity that you have to add, because you're going to have to balance how those or what different methods of transportation, how you set up and so forth manages to reduce the footprint, CO2 footprint. As far as supply chain disruptions, this is our disruption index, and what you see is that the number of disruptions continues to increase. And as I mentioned earlier, it actually has real world dollar implications. So here's just an example from last year, where you saw the number of shocks and all the shocks to the system, and how they directly correlated to real cost for any of the manufacturers or anyone shipping goods from China to either Europe or the US. And as I mentioned, we believe that the number of supply chain frictions is only growing, and is going to continue to really strain and make those think about, like I mentioned, I'm going to say it probably now, this is the third time, where the first principle thoughts of like what you can rely on for it to be true are fundamentally changing, which means that you have to rethink your layout and your value chain differently. So this is really then getting into that global footprint strategy and how you think about it. So, we're kind of coming back full circle on this chat about globalization. And so each of the dots represent different time frames. So the blue dot represents what we are characterizing as the golden age. So really, 1980 through 2020. Then you have today, which is the white dot, and then the future is the red dot. And so when we think about the major cost drivers for when you think about building your footprint and how you think about building the value chain, the things are actually changing. So in the golden age, as I mentioned, you had very low labor cost. And now what we're seeing, China's a great example, increasing labor costs, continuing to rise. And so what historically has been cheap is now becoming a lot more expensive, right? And we're seeing definitely that shift from left to right. Tax support has historically been fairly low. It's been usually relegated to very local communities providing the tax incentives, where today we're seeing a bit more, right? We're seeing, IRA, we're seeing other subsidies from state and local governments on providing incentives to move manufacturing in. We saw before demand predictability very high, which means that you can manage your supply chain much tighter. So the amount of safety stock, the amount of inventory in process, all of those things could be very streamlined given high amount of predictability. And what we're seeing is that all of the shocks are making that very difficult, which is why we're seeing the direct impact on a lot of shortages. And the same thing on supply predictability. The ability to get materials and things are becoming harder and less transparent. And these shocks, we think, are making it very difficult. And then similarly, we saw a time of lower transportation cost, and we see the same thing. It's much more expensive today. So, I think these are all things to be carefully thought about when kind of setting up new manufacturing footprints, especially for, what we characterize as the more higher technology products. Now, we do view it slightly differently when we think about legacy ICE products, right? So the question we often get is, well, should we be moving our ICE products of today? And so today we've seen that there is impact. So the gradients are red is, negative impact, blue is a positive impact, and the grayish white color is more neutral. And so what we would say, or what we've seen, is that while things have become more expensive across different cost considerations, it still isn't as much as enough to promote moving. Because if we then say, okay, let's build a new facility and let's see how that has implication on our cost. And what we would say is, okay, well, if we move it to, from China to, let's say, somewhere in the US, our operating costs are clearly going up because labor is more expensive. The capital investment, well, this was already made, and now you may have to reinvest and set up that a new capital investment. So much more expensive. Transportation costs might go down, which would be a benefit. Working in capital may go down, but the people cost and getting the transition of people cost is likely to go up. And then obviously the supply-based costs are also going up because you're going to want to regionalize some of the supply base as well, which means that since all of these costs are going up, so do those costs. So ultimately what this is saying is like, hey, it wouldn't make sense to move those things. So therefore, we think it makes sense that we still maintain global footprints for a number of these products, especially when a lot of the investments have been made. However, there are cases where that fundamentally gets challenged. And I think a great example, as I mentioned earlier, was kind of the Ukraine war, right? Where the disruption to the industry cost so much additional money that, of course, it made sense to relocate and make it because this was going to be a much worse situation. So there will be situations where folks will need to rethink that. If any of these kind of, sway the balance. But I think these are more of the outliers. And I do believe that global supply chains will continue to sustain. It's just that people will need to reconsider the formation of those and maybe manage the risk differently. So kind of bringing it all together, what does this mean for the auto industry and for the different market participants in it? The first thing that we believe is that this means that firms are really going to need to strengthen a few things. They're going to need to strengthen their processes, competencies, and tools to really react to this volatility in a fast and expedient way. They're going to need to have local management teams that can be very adept at kind of addressing the local issues and being fast. And then we think that folks are also going to need to continue to strengthen their internal ESG capabilities as customers, and the actual organizations or companies within their ecosystem are also going to have demands put on them. And so in order to participate in the market, you're going to need to work on those things. We think that firms will need to reassess a number of things as well. So this is one, the manufacturing footprint. So really, are you set up the best way to manage cost and risk? Second, we think financial targets are going to be a big question as well. And I think because what's been really interesting as well, when we talk about kind of the shift to the US market in manufacturing, is that what we've been seeing is, or the big next thing that I'm concerned about is, will we actually have a strong enough manufacturing base to actually support all of the new manufacturing that we're hoping to bring into the US? Because there was actually a pretty significant labor drop coming out of COVID, because you actually had a pretty significant number of people that retired. You had everyone that was part of the Great Resignation that really moved out of manufacturing jobs into new passions or things that they're interested in doing, which has really resulted in the manufacturers having a hard time keeping staff. So what we've been seeing pretty strong across the industry is a lower reduction of production efficiency. And why is that important? Well, that's important because it actually will potentially change the economics for these products. Because many times when a supplier goes to sell a product to an OEM, it has very specific manufacturing efficiency expectations in there. But if fundamentally the market is shifting or the industry is shifting to where we're becoming less productive, that obviously is going to have an implication either on the financial targets or how we think about pricing products. So this is also going to be something to watch and be mindful of. As I also talked quite a bit about, people need to reassess the product and technology portfolio, because I think many have operated under a global view, and I think regional nuance is going to matter more going into the future. So that is something that many will need to reassess, which then ultimately drives kind of the reevaluation of different participation models. So where do we want to actually, as a firm, participate, which regions, which segments, which products, and does any of these kind of changes in structural setup make us rethink about how we want to play in those markets? And it also is meaning that people are rethinking or reevaluating their regional supply chains, because really it's been historically dominated based on where the predominant manufacturing is. But if we start moving the manufacturing around it, it's going to change the regional setup, not necessarily only for the tier ones, but also for the tier 2 and tier 3 supply base, which is going to be a pretty interesting thing to watch. And then it's not meant to be all doom and gloom, right? Because we do think when you have these major structural shifts and changes in the market, it does create new market opportunities. So we think that there's going to be a lot of opportunities for market participants to think differently, come up with creative and new solutions, and maybe move into white spaces. And then partnerships are going to be fairly important, especially when we think about managing the R&D and investment costs, because there's still a lot of investments that are going to need to be made. But also when we think about addressing some of the CO2 requirements, as I mentioned, you can't do it on your own. So we think there's going to be quite a bit more partnership in trying to address some of the CO2 challenges. So that concludes my presentation, and I can now switch to Q&A.
Very good. Thanks, Brandon. Yeah, Brandon, when I was listening to your talk, when you were talking about the end of globalization, and there's a lot of research that I've been watching for a number of years that really didn't talk about as much globalization as regionalization. And regionalization actually isn't that new, because the U.S. When if they wanted low cost support, they just went south. When the EU wanted low cost support, they went east, and that's still the case. And actually those uh, supply chains are actually growing. And actually, we see the Chinese coming to Mexico now, and so that they're looking at other ways of meeting their supply chain needs and low cost needs. Um, I just wonder about how that is going to play out for the predictability that you were talking about for the supply chain. When you move to a more regional supply chain, do things become more predictable compared to the past? Now, the past things were pretty predictable, but recently they are not. How do you see that playing out in say over the next 10 years?
I think it's going to take time, to be frank, and a lot of it is going to be largely dependent on some of the geopolitical tensions, because you can regionalize final assembly, you can regionalize some of the component manufacturing, but what you can't regionalize is some of the base materials. So if you go all the way back to chemicals, if you go back to rare earth materials, all of those are still being predominantly processed in China because of the lower emissions standards, the lower safety standards, those sorts of things have allowed those value chains to stand up and be built and proliferate. So now they have very dominant setups there, and we've seen in the past that those have been used geopolitically to kind of push their agenda. So I think it's going to still take time, because like a simple thing like magnets could really put our industry at our needs, right? They go into a lot of our products, whether it's braking, whether it's steering, whether it's the motors. There's a lot of spaces where these rare earth materials are being used. So until we see some of those things being de-risked, I think there's still a higher risk of volatility.
Do you think that one of our attendees says many companies have tried to leave China? Which countries can be alternative countries for China? Vietnam, Thailand, Africa? So what, or is it more of a regionalization story?
Well, I think there's some of that, but if we look at just, and I'm not anti-China, so it's just I'll speak to some of the things that we've been seeing. It's just a fact, but like the Belt and Road Initiative has been very focused on developing Africa as an example, right? And they've been very strategic in building up the infrastructure there and claiming resource. Same thing in Chile. If we think about lithium, which Chile has some of the largest reserves in the world, if not the largest reserves in the world. And I think China has, I think, mineral rights on almost 50% of that. So it's just technically they've been able to do that. But what we're seeing is, if I look at like private capital, right? So private equity has been heavily looking into these kinds of projects on US soil. And what you're seeing is a lot of government and political support on financially making those businesses viable. So, and whether that's, US or Mexico, I think it's a little bit more flexible, or even if you think about Canada's, because Canada actually still has quite a bit of mineral reserve as well. And do we anticipate more production happening in those regions? And my answer is I think longer term, yes, because I think many countries, not just the US and others, are recognizing that they may have to change the way that they think about the value chain and their strategic positioning going forward.
Yeah. Do you see the companies making the necessary changes? Auto companies and suppliers and manufacturers making the necessary changes that you talk about?
Yeah, the supply base. I mean, from a regionalization standpoint, I think there's been a lot happening. Battery production, I think, is one of the great examples. I mean, still, it's only the cell manufacturing. I think we still have a shortage on the cathode materials and some of the other material processes that you actually need to make a battery. But we're seeing those large investments actually starting to take place. And this is what's interesting, is like the center of gravity for some of those may fundamentally shift, as long as the subsidies continue to exist with IRA, right? Because like literally LFP could be exported cheaper than what China can do it at if we continue to see all the tax credits that go towards that. So it's going to be very interesting to see how that plays out, how long that support continues to stay, in the market, and how the actual structure kind of develops and develops going forward.
Chris or Greg, do you want to jump in on any of these questions? Feel free.
I guess I have a question. With regard to the EV transition, have you looked at implications for utilities, also the energy industry in terms of the oil industry and its response? And because, we need the electricity, right, for these vehicles. And right now, it's not necessarily an issue because we don't have large, deployment. But as we, increase and move further in the transition, there are going to be capacity issues and infrastructure issues related. And just wondered if you've studied any of the other sectors here that are related in terms of this transition.
Yeah. So within our U.S. practice, we have colleagues that work with utilities and also those that work in the chemicals space. And so I haven't personally studied it myself, but we kind of bring all of our brains together to kind of think about the implications. And some of the things that I can tell you is what's been really interesting is if you look at like the oil and gas industry, they are investigating a lot of alternative energy opportunities. So they're really starting to think about the diversification. I can't even tell you the number of projects that we've been running as an example, and thinking through like the materials that go into batteries as an example, and how could they transition into a materials player? What part of the value chain could they participate in? They're looking at energy storage is another huge topic that we're talking to everybody about. So how do they build up the energy storage projects and so forth? The other big topic that, is kind of funny because it feels like it pops up every, 20, 30 years, which I know is like, I would have been pretty young, but nuclear, right? Micro nuclear reactors has become another big topic again. So all ways of trying to supplement energy creation and or storage. I know there's still a lot of questions about the upgrading of the actual infrastructure and lines, but I can tell you that most of the utilities are feverishly working on those topics and trying to figure it out.
Thanks.
Yeah, one of our affiliates, National Lab in Pacific Northwest, has been doing a lot of work on measuring the resiliency of the lines, especially in the Northwest area, but also other parts of the U.S. That's one research project that they've been working on, I think, for a number of years now.
Mhm.
Now, Chris was bringing up he brought up the point earlier of the advanced manufacturing tax credit that you mentioned, Brandon. And this is, we see that Chris was talking about it as a potential way of reducing the cost of vehicles, of EVs for consumers. Do you see that as how it will play out, or is it more being played out more by the manufacturers and how they might use it either for their own profitability or for the R&D?
Yeah, I think that it was the car credit was meant to be more like per vehicle credit was meant to be more the consumer piece, and that the other piece was really meant to drive the economics for getting people to actually make the huge capital investments required to enter those spaces, because they've historically just not been economical. And even today, if you tried to do it, it's not economical unless you get these huge subsidies. But the subsidies, then they can actually make reasonably good money. And that's where you're actually seeing, because they believe they're going to make a disproportionate amount of money relative to where else they could in the world. We actually think some of them are probably making the U.S. the base for some of their like core or the earlier investments. So the U.S. may have had a different prioritization than it does today.
Mm-hmm.
So it's really weighing in on how they're thinking about their capital deployment. So if we think like LG is a great example, I'm pretty sure that they thought long and hard about, where they were going to put ESS. I mean, I would have assumed or thought that they would have prioritized, Europe first, just, based on some of the developments and the speed of that market transitioning. But I think the economics are just too good in the U.S., and so they're prioritizing that. So I'm not sure how much of that is going to benefit the consumer. To be honest, I think it's getting the companies to invest and put money here that they otherwise probably wouldn't have.
Mm-hmm. Good point. We were talking a lot about some about the Scope 3 emissions. How are manufacturers dealing with that story right now?
Yeah, so what we're seeing is a lot of them are now setting in place like surveys and collecting information from their supply base.
Mm-hmm.
So they're starting to track their suppliers and doing reporting based on that. And our view is that's going to continue to step up as they keep ramping up their requirements. The other thing that was really interesting is that I think a lot of the supply base anyway, because I speak to them a little bit more than the OEMs, they went out and made some pretty bold commitments before they had really thought through what was going to be the implication or how they were going to get there.
Yeah.
And so we've been spending quite a bit of time helping a number of our clients come up with the strategies now that they've made the commitments to get there. But yeah, I mean, they're making a lot of progress. I mean, it's been pretty impressive to see how quickly they've kind of taken hold of this, because I don't think it's just about the reduction of CO2. I think a lot of what they're finding is that there are ways also to save money by doing it. And I think that's been the really helpful thing, right? Is like there's been ways to save money and be more cost effective by thinking about these topics. It's just not, for the planet.
Greg, is that what you're seeing in the Scope 3 analysis that you guys are working on?
Well, we actually did a project with Ford on a framework and inventory for Scope 3 with suppliers. And to actually estimate for Ford to disclose what their Scope 3 emissions, we had to estimate those upstream emissions, because suppliers, it's not like you could take the whole supply base and the amount of parts and components and conduct an inventory. Just ask each supplier, what is your carbon footprint for that part? That database is not there yet. I think they're asking suppliers for that information, but we had to estimate it using kind of national average generic, data from, industry average. But we're moving there, and that's true not just of, the auto industry. It's all of the industries. They're looking for suppliers to come up with this data, but it's not something that Ford can create, or we can create now an inventory using supplier specific emissions. Our models are all generic, but I think eventually we will probably get there. Just going to take some time.
Yeah, so it sounds like right in line with what I was saying. It's like they're starting to ask for it.
Right.
There's certain parts that they're getting. There are other parts that are obviously clear gaps, but they're recognizing it's coming. So now they have to figure it out. They made commitments, and now they have to figure out how to track, measure, and actually do it.
Right. And there's big differences in terms of, where you're sourcing your materials. Is the aluminum made with, from a coal-fired power plant, the electricity, or is it renewable energy, hydropower? Big differences in terms of footprints, in terms of cost. Mm-hmm. So, I think the theme of regionalization and really understanding, supply chains and diversity is very important.
Chris, did you have any questions for Brandon?
Yeah, I was just gonna kind of dig a little bit deeper on that, on the supply chain trade-off between efficiency and resilience. And really, over the past few years, we've seen the downside of focusing far too much on efficiency. How much do you think, is this a long-term shift to where automakers are really and suppliers are really gonna value resilience a little bit more?
Well, so historically the answer has been no, right? Because, and the reason why is because the supply and demand predictability kind of went back to a normalized, or at least a predictable state. I think our view right now is we're entering this period where at least the next 10 years, I think are going to be really difficult to predict. So I think the cost to offset the new level of predicting that you can do. So there's more volatility. So your ability to actually make the predictions the volatility is much higher. So there's an actual real cost to that. And now it's kind of going to levelize at where they can manage the cost with then the setup, right? And I don't know where that equilibrium is going to hit, but it's definitely not going to be the super long supply chains that we have today, right?
And Brandon, when you were talking about China, it reminded and their emissions and their strategies, and they've been pushing EVs. They have got 20% NEVs maybe or last year or something like that in new vehicle sales, and multiple years of decent NEV sales, which makes it look like they're making progress. Yet they're still building coal-powered power plants. Why are they doing that?
Okay, but this goes back to the point that I was making during that, like governments and what they're trying to drive. And so how would you prioritize carbon reduction relative to other things in their agenda?
Yeah.
And so this is what I'm saying is that I think it's lower on their agenda compared to, economic power, technology leadership, and energy independence. Mm-hmm. Those three all have a higher priority than smog. Mm-hmm.
Yeah.
Like
Yeah,
they're going
you
to
gotta-
need to deal with smog, right? Because they have like people and health concerns. So it helps address that. It's just my personal view is that the other three that they're going to rate higher. So
Yeah.
you're going to see that their decision making is going to bias towards making sure that those three are met over the other.
Very good.
But
All
it
right.
just quickly, if there's a tracking of the footprint with the supply chain, then that would make a difference. But right now, there isn't that tracking. So, you know, if they're using coal-fired power to produce their steel or, you know, other automotive parts, components, the OEMs aren't quite there yet to differentiate suppliers on carbon. But as we move there, then that's going to be an incentive for them to also focus on carbon for their electricity.
All right.
Yeah, or they're going to move value chains. Like I didn't, you know, I know Bruce, you made the comment about the Chinese are moving to Mexico. I don't think they're moving to Mexico to reduce cost. They're moving to Mexico to still have access to the U.S. market and not have
Absolutely.
anything made
Absolutely.
in China.
Absolutely.
So
Yeah.
Greg, you know, just based on that point, I think that they may address that differently. You know, there's
Mhm.
still a giant China for China market.
Yeah. All right, guys, I think we're going to have to call it.
All right.
Brandon, Chris, Greg, I want to thank you, all of you, for your support for the conference and attending and presenting. Very good presentations, very good insight into what we see happening now, and then what we'll be seeing over the next 5 to 10 years. So again, thank you all. Chris, you got to go. Feel free to check out now, and I'll thank we thank our affiliates for supporting us. We thank our attendees for continuing to come to the conferences, both online and in person. Look forward to our next conference, which is the next wave. We may see Brandon again in July, talking about future of automotive batteries. So we'll be looking forward to that, Brandon. And also again, thank you to all our support staff, Carrick, Alkire Online, Lydia here at the U of M. Take care, Brandon and Greg, and everybody online. See you next time.
Thanks a lot, Bruce, for organizing it.
All right. Bye-bye.
See you guys.
Bye.